All right, hello. I'm not sure who you are that requested that one problem, but I'm gonna go grab those problems.
All right. Hello. I'm not sure.
Oh, just a second. Okay, I should probably have that closed. All right, I'm gonna go find those problems. I might not be able to like clip them exactly, but I can talk about them. For the if you're talking about the purple form, that might not be one I can just clip the problem on. Purple is I know where to get that. Okay, so you had requested 14, 25, and 29. Scroll down to there. Okay, yes, all right. 14. All right, so we want to know about the slope of the tangent line to a curve that's defined implicitly. But I did see I was working on this problem with somebody else, not this week, and he had started down kind of a different road, and I kind of liked what he was thinking, and we ended up working it that way, and it worked out just the same. So I'm gonna do this one two different ways. So they give you square root of x plus square root of y equals 2, I think, yeah. And they're talking about the point where x is 9/4 and y is 1/4. And we want to know the slope of the tangent line. And so we need dy dx. So I think the way that most people would attack this is to rewrite this as x to the 1/2 plus y to the 1/2 equals 2, and take the derivative of this equation as it is with respect to x. So we'd have 1/2 x to the negative 1/2 plus 1/2 y to the negative 1/2 times dy dx for the chain rule is equal to the derivative of 2 with respect to x, which is going to be 0. And then you'd kind of plug in 9/4 and 1/4 and solve for dy dx and get yourself an answer. And so, the negative half power of something is 1 over that square root. So I have 1/2 times 1 over the square root of 9/4, which would be 3/2, plus 1/2 times 1 over the square root of y. 1 over the square root of y would be 1 over a half. And then there's the dy dx, and that's going to equal 0. So if I'm multiplying by 1 over 3/2, that'd be like multiplying by 2/3. So 1/2 times 2/3 plus, okay, well, you could even just like multiply straight across here. Either way, you're just going to have 1 dy dx, that equals 0. And say dy dx equals negative 1/3. I think that's the standard way of solving this one. But then, guy I was working with one day this week, he had like started to solve for y, and I think that's something we could do. We could say square root of y equals 2 minus the square root of x. Now the issue was he made an algebra error and tried to like square both sides and said that was 4 minus x. And if we square both sides of this equation, we need to do FOIL. Yeah, it's still visible to you. All right, and I'm going to say, okay, that's 4 minus 4 square root x plus an x. And you can then take the derivative of this and just say, all right, well, dy dx equals 0. X to the 1/2's derivative would be 1/2 x to the negative 1/2, and then plus 1. And then if you plugged in x to the negative 1/2, you're going to be like, negative 1/2 times 1 over 3/2 again, plus 1. And then that comes out to be 1 minus, wait, hold on. Is that right? Negative 1/3 plus 1 is 2/3. What happened there? Negative 1/2 x. I'm not sure. It's supposed to come out the same. I think, yeah, I may have made an error in here, but I'm going to move on to the next question that you requested. Okay, so you said 25. All right, yeah, we definitely like this problem type. All right, So the function f has a continuous derivative, and they give us a couple of values of f and a value of the integral of f. But the real question here is the integral from 0 to 2 of x times f prime of x dx. Okay, and this is going to be a product, the type of product we're going to need to use u dv on. Okay, yeah, the foiling is the type of thing you might need to be run about today, right? But the good news is we don't actually have to do that all that much. The situations where we'd have to square a binomial, like especially the area volume, oftentimes those are set up but don't evaluate. And with that one, the first one I worked, I mean, I think that 99% of people are going to try to work that one implicitly. Or maybe I'm wrong. Maybe people are trying to solve for y regularly on that problem. I just hadn't been using it that much. Okay, so this one's going to be u and dv. So you think to yourself, ilate. But, f prime of x, we don't know anything about it. So the idea with ilate is we're choosing u to be something we want to take the derivative of and dv to be something we want to take the antiderivative of. And we don't really have any information about f double prime. So I don't think I want to take the derivative of f prime and the antiderivative of x, even though I can take the antiderivative of x. I think it would be better to take the derivative of x, which is 1. It sounds simpler. And the antiderivative of f prime, which we know is going to be f. So I'm going to say u equals x and dv equals f prime of x dx. We're going to need du and v. And then integral of u dv equals u times v minus the integral of v du. And if we're integrating from 0 to 2, that part of the antiderivative will go 0 to 2, and this part of the antiderivative will go 0 to 2 also. And then we're just going to kind of fill in the pieces. Okay, this is going to be equal to u times v, x, f of x, minus the integral from 0 to 2 of v, which is f of x, du is dx. All right, and I forgot to, okay, that's going to be 0 to 2. And then I'll have 2f of 2 minus 0 times f of 0 minus the integral from 0 to 2 of f dx. That's a little more room to work here. And I can look up this. This is given to us in the statement of the question. They said it's 7. So subtracting 7 there, that's going to be a 0, and 2 times f of 2, and you grab that, f of 2 is going to be 5, and it doesn't matter what f of 0 is, so I've got 10 minus 7 is going to be 3, and that's answer choice A. And then I'm also doing number 29. Ooh. All right. Yeah, okay, you got me with this one. So I think I'm going to copy the problem. So we're looking at the limit as n approaches infinity of 1 over n multiplied by 1 over n here plus 2 over n. I might give you a second one. Okay. So here we've got this one, and our options are like some definite integrals, and so the idea here is like, what's the connection between the limit of the Riemann sum and the definite integral? So what I have, oh wait, not 1/2, that was supposed to be a 1 over n. What I've kind of trained y'all to look at when you're doing one of these is that the integral from a to b of f of x dx is, it's the sum of f of x times delta x. And delta x is the width of the interval divided by n if it's going to be like evenly spaced. And we're interested in as the limit as the number of rectangles goes to infinity. So the best thing that we can do to narrow down answer choices is to look at this b minus a thing, which is right here, and say that our interval that we're integrating over has a width of 1. Now, in this situation, it only helped us eliminate one answer choice, but most of the other ones, that helps us like get down to 50-50, which is kind of big for this type of problem, because these are a little tricky, especially this one. But the way I was able to, kind of figure this out is by looking at the integrands here. Actually, let's say I looked at the first term. Okay, and as n approaches infinity, 2 plus 1 over n, well, that's like a half, right? And then as n approaches infinity, well, n over n, this thing is always 1. So I'm looking at this, and I'm saying, like, my integrand has to start at 1/2 and end at 1/3. And there's only one of the answer choices that makes that happen, and it's B. Because I need the, like, at the bottom end of my region I'm integrating on, I need to be adding up a half and then getting towards adding up a third, which would be like 1 over 2 plus x, as x went from 0 to 1. But that one, like, there's no shame in missing that type of problem. If we can eliminate that one down to 50-50 and then just, randomly guess, then I'd feel good about that, especially with having like 100 people taking the exam. Let's see, number 10 on the 2016. Yes, definitely. That one might be worth it for me to grab out of. Let's see. Do I have that one? Does not look like I do. All right, let's go back there. Think about how I need this. Second, please. 11B on page 321 of the review book. Totally, I know what you're talking about. I will get to that shortly. All right, I'm gonna briefly take that away from your field of vision. This one posted for people to watch overnight if they decide they don't want to start reviewing calculus until like 2 a.m. or something foolish like that. And I don't want to see my login information. So I'm gonna I know where I can get this on the download from the school files. Let's see, shared folders. And Chrome 2016. Oh, number 10. Okay. Okay, there's only one number 10, so. Oh. I know this problem. But it's on one of the release tests, so I'm gonna just clip it in. Make it visible to y'all. Alright, there we go. Alright. F is the function, f is 3 minus 2x. If g is a function with derivative given by g prime equals f prime times x minus 3, on what intervals is g increasing? Okay. Oh, this is a good one. I think what we're supposed to do here is we're just actually going to write a formula for g prime and make a sign chart or a sketch graph. So I've got f, 3 minus 2x. F prime of x is going to equal -2. And so if I've got g prime of x equals f of x times f prime of x times an x minus 3, we just are going to need to make a sign chart here and see where is g positive and where is g negative. I can't. It has been long enough now that I don't remember this year if y'all were preferring the sign chart method or the sketch a graph method, but I'm just going to do both, and you should do whatever you feel more comfortable with. I want to say that maybe this year y'all felt better about the sign chart method. I personally prefer to sketch a graph, but because I know I'm prone to arithmetic errors, but that's not a big deal. So we'll do both ways. So we can make a sign chart, and with the number of negatives here, the sign chart might be the way to go. I'm going to say, what are the zeros of this derivative? I think if x is equal to 3 divided by 2, like 1.5, we're gonna have g prime equaling 0. Yeah. So I've got 1.5 here, and then I've got x equals 3. This is not going to contribute a 0 to g prime because -2 is never able to equal 0. And so I'm going to choose kind of a representative from each section of the real number line. So like something between 1.5 and 3, that's 2. And then I say g prime of 2, and you're probably doing this either mentally or just like writing down signs. But I'm just going to say 3 minus 4 is a negative number, -2 is a negative, and I'm doing 2 minus 3 is another negative, 3 negatives is a negative. Okay, so I don't know if we can add, okay, yeah, that's not really, I mean, it might help us eliminate, C and D and, yeah, C and D, but I'd say we could, we're going to need to do the rest of it. So something beyond x equals 3, I don't know, like x equals 10. I'm going to have 3 minus 20 is a negative number. -2 is negative, and 10 minus 3 is positive. Okay, so I got positive over here. Something less than 1.5 would be 0. I think it would be a good choice. 3 times -2, so I've got positive, negative, and 0 minus 3 is negative, so this is going to be positive as well. Okay, it's increasing through here and there, and I'm looking for 2 intervals, yeah, here. And remember that, like, as far as increasing, if you're thinking, wait a second, like, it's not really increasing at 3/2 or 3, well, really it is, but we don't need to worry about the endpoints of intervals of increase, decrease, concavity. That's just a discussion for another class. Okay, I'm also going to go in here and say sketch a graph is a viable technique here. We look and we see, okay, g prime is going to be a second degree polynomial. And if I was to multiply it out, I would be having a negative leading coefficient until I then distribute it in the -2. So it's going to be a second degree polynomial with a positive leading coefficient. And I see it's got these zeros at 1.5 and 3. And so I can say, all right, it's a parabola and it's positive here and there. And that could save me a little bit of time. But if you're not the type of person that's looking to sketch a graph, then you should make a sign chart. But if you are a graph sketcher, then sketch your graphs, and it might be a little faster. Okay, so that was number 10. 28 and 84 were the next ones requested. Wait, 28. Am I looking at the right? No, I'm not looking at the right thing. It's 28. Ooh, okay. Understand why you would ask about this one. Okay, so this one, I don't know what's going to happen here. Let's just. All right. Particle travels along the x-axis so that at time t greater than or equal to 0, its velocity is given by v of t as that. What's the total distance the particle travels from 0 to 3? Okay, total distance traveled is where we're going to have to integrate the absolute value of velocity. We're going to integrate speed. It's just like parametric where we're integrating the speed formula, except in one dimension. Particle traveling along x-axis, speed is just the absolute value of velocity. So what we need to do is integrate from 0 to 3 on the absolute value of v of t. And because this is number 28, this is no calculator. And this is something we're going to have to do by hand, and we're probably going to have to split it into multiple integrals, and it's not going to be the best thing ever. Really don't like this problem type, and I didn't have you do it very often, and it's pretty rare that they would have you do it. And I don't But I don't know what to predict for tomorrow because we don't ever even see the multiple choice. So, and it is something that it's a reasonable calculus question. It's just going to be somewhat intensive. So what we're going to have to do is factor VFT and figure out where VFT is positive and negative. Because if VFT goes negative, I need to be very focused on that interval and make sure that I'm counting that area positively. So I've got VFT equals that's 4 and 2, right? Yeah, t minus 4 times t minus 2. Okay, so if I sketch the graph of this, it's interesting that twice on this you kind of needed to sketch the graph of a quadratic. We'd see that v of t goes negative between the two zeros, between 2 and 4. So what's going to happen if I draw a bigger picture of this, and maybe that's not drawn to scale, but maybe this is 0 and that's 2 and this is 4, and we're trying to integrate to 3, which is going to be halfway between the zeros, so I know that's going to be like at the vertex. I'm going to have to split this up into 2 separate integrals, right? I'm going to have to do the red one, and then I'm going to have to subtract the negative number I would get when I did the green one. Okay, and so what I'm going to do is I'm going to go over here for red. I'm going to say, all right, integral from 0 to 2 of velocity is t squared minus 6t plus 8. And that's going to be 1/3 t to the third minus 3t squared plus 8t from 0 to 2, which is going to be 8/3 minus 3 times 4 is 12 plus 16. Okay, so that's 8/3 plus 4. And I'm hoping that, I'm not going to do too much other simplification because maybe the arithmetic on the other one will lend itself well. I'm going to say that's the red area, and then the green area is going to be down here. I'm going to integrate from 2 to 3 on the same thing. And so that's t squared minus 6t plus 8. And I see it's there's definitely some sort of trick to be done here because it's the same endpoint. Especially because I already simplified here, I don't recommend you try to engage in any trickery. Just grind through it. Could you make sure you get the same antiderivative both times, right? I'm just gonna make sure I'm not going too fast. Yeah, I'm good there. All right, 2 to 3. All right, when I plug in 3, I'm gonna need more room. I get 1/3 of 3 to the third, so 1/3 of 27 would be 9. Minus 3 times 9 is 27 plus 24. And I'll simplify that in a second. Okay. All right. And then when I plug in t equals 2, I'll get 8/3 minus 3 times 4 is 12, plus 8t was 16. So it's going to be the same thing. And I forgot to make this negative, but it's okay because I know that when I'm integrating from 2 to 3, this is going to be the negative part, and I'm just going to be subtracting that. That's why I split it out into 2 completely separate things going on. So 8/3 plus 4, because it was minus 12 plus 16. Okay, so I've got 9 minus 3 from the negative 27 plus 24, that's 6. Minus 4 is 2, so 2 minus 8/3. Yeah, that's a negative number. So I've got 8/3 plus 4, and then I'm going to subtract. So my actual answer is 8/3 plus 4 minus 2 minus 8/3. So I'm going to have 4 minus 2 is 2, and then 8/3 plus 8/3 is 16/3, so this is 22/3. That was a lot, right? Stuff. Okay, and then, 28, and then 84. Let's see what that one looks like. Yeah, I like this one. Yes, I know which one you're talking about, the polar curve, and that one I'm gonna have to bring in the calculator for to really show you what I'm talking about. And even still, I'm not sure if the online or the not online, but the computer calculator is gonna show it exactly what I want it to. But I have a feeling we can make it work. All right, so this one, number 84, the figure above shows the region A, which is bounded by the x and y axes in the graph of f of x, and the vertical line x equals k, and k is moving. And k is going to be increasing at a rate of pi over 4 units per second. How fast is the area of region A increasing when k is pi over 6? Okay, what we're going to need to do is write an expression for the area. The area is going to equal the integral from 0 to k of f of x dx. And so we just call this A, maybe. They say k is increasing at a rate of pi over 4 units per second. That's going to mean to us that dk dt equals pi over 4. And then what I'm going to do is say, all right, well, I need to take the derivative of A because that's what they're asking, how fast is the area of region A increasing. So the derivative of A with respect to time is going to be, okay, well, take the derivative of A with respect to K, which is kind of like its independent variable. So that would be f of K, and then multiply by the derivative of K for the chain rule. What do you ask me about this one sooner? Because this one's a lot like one of the ones from the secure booklets, one of the pre-response questions we did, the area volume, where they even called it K. But the problem was that was a lower bound of integration. That proved particularly tricky for us, but that was a good one. Especially for those of us that came back and looked at it and hacked our way through it. I think there was definitely some understanding to be gotten out of that problem. But it's the same thing here. So I'm going to say, all right, f of k is, okay, I guess f of pi over 6. Let's go off to the side and say, what is f of pi over 6? It's going to be equal to sine of pi over 6 divided by x, which is pi over 6. All right, so I'm thinking pi over 6. Okay, that's over here. Not very high up. It's a 30, 60, 90 triangle. On the unit circle, all of the triangles have hypotenuse 1, and the short leg is a half, and the long leg is root 3 over 2. And if I'm doing sine, SOHCAHTOA, opposite over hypotenuse, that's going to be a half. So 1/2 divided by pi over 6 is like multiplied by 6 over pi. That's going to be 3 divided by pi. What we're actually looking for here is dA dt at the point where t equals pi over 4. No. K equals pi over 4. It's never t in these related rate problems. So this is going to be f of pi over 4 times dk dt, which we already happen to know is pi over 4. Definitely need more room here. And so we know f of pi over 4 is 3 divided by pi. And then we're going to be multiplying by dk dt, which we know is pi over 4. And so I'm going to have 3/4, which is answer choice B. Okay. And that was number 84. Okay, next. I'm going to do number 11B on page 321 of the review book. So I'm talking about acing AP Calculus here. And I think that I'm going to drop a link to this book in the chat because it is just great. Just in case there's anybody here, let's see if I can get that. No, that's I can actually run the search, yeah. Just in case anyone here is not in my class, doesn't know what I'm talking about, this is a good reviewing AP Calculus book. And so I'm going to be working number 11B on page 321. It might take me a second to dig up, but I can do it. Okay. I guess I'll probably be able to tell. I assume you're talking about the numbering in the book itself. There's no such number 11b. No, yeah, I know what you're talking about. So for A, yeah, sure, why not? I think I'm gonna have to do A as well for B to make any sense. And this is gonna be a problem talking about like the known Maclaurin series. This kind of starts you off with e to the x or something, somewhat related. So, actual Google Drive page count. Okay. So you're not talking about this Maclaurin series here. Unfortunate coincidence that that one also happened to have a E on it. All right, let's go back. So, Google Drive page count. Let's see. All right, it's not too far off though. Oh no, so that is the problem you were talking about. Okay. I'll reassure myself that this 311 does not have any problems on it. Okay. Great. Yeah. This one's a little tricky, but I could see there being one kind of like this. Okay. Great. The first four terms in the general term of the Taylor series for f. Okay, and just to be safe, I'm going to start with e to the x. Let's start with what I know. E to the x is 1 plus x squared. And they're asking for first four terms and the general term, so I might just do that starting with e to the x. Okay, so f is just e to the negative x, and so we're just replacing x with negative x plus negative x squared over 2 factorial plus negative x cubed over 3 factorial plus negative x to the n over n factorial after a few, and then beyond that. Okay. And that's the first four terms in the general term of the Taylor series for f around x equals 0. We're going to use the result from part A to write the first four non-zero terms in the general term of the series expansion for g of x, which is 1 minus x minus f of x, all divided by x. So what we're going to do, we're going to start with the numerator. So 1 minus x minus f of x, it's going to be 1 minus x minus the Taylor series for f, which is going to be 1. And then now I'm going to actually go in and deal with the fact that, okay, odd numbers of negative x's is going to be a negative and even is going to be positive. And first four non-zero terms, well, that's going to be annoying because I'm going to have to bring in more, but that's okay. So 1 minus x plus x squared over 2 factorial. Now, right now, I'm going to copy more terms because I can see that the 1 minus x and this subtracting 1 minus x, I'm going to lose those terms. So I need 2 more. Minus x to the 3 over 3 factorial plus x to the 4 over 4 factorial minus dot 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 plus negative 1 to the n, x to the n, that's negative x to the nth power is negative 1 to the n, x to the n, over n factorial. Okay, and we're subtracting all of that. That's the general term is going to be interesting here, but maybe we'll be able to figure this out. I'm going to now actually say 1 minus x minus the 1, that would be 0. Plus the x back would be, another 0. So it'll be x squared over 2 factorial minus, it'll be negative x to the 2 over 2 factorial. Okay, well, I'm not sure what's happening here. Negative x squared over 2 factorial. Once I distribute this negative into all this stuff, plus x to the 3 over 3 factorial plus x to the 4 over 4 factorial. No, it's going to be a minus. Plus dot 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 plus. All right. It might need to be like an n plus 1 situation. Yeah, it does feel like n plus 1. X to the n over n factorial. I'll tell you why it's n plus 1. I'm looking at what has negativity on it. I have it here and I have it here. And these are even numbers, right? So when I have say x to the 2, when n equals 2, I need to have negative. So I would do an n plus 1 there to make sure I had that. And that would be the first four non-zero terms in the general term of the series expansion around x equals 0 for g of x. And, okay. Then number 86 on the 2012 exam. Yes. I just freeze that. Yes, Ayush, for sure, there is wording that you should know. One thing I was discussing with somebody yesterday that I don't think I did a good enough job explaining in my classes this year is that Euler's method, you only do Euler's method if you see the words Euler and method. Kind of like Lagrange error bound. I'm pretty sure. Nah, I think there's one where I saw where you like had to implicitly know, but like Lagrange error bound like 99% of the time. Okay, and then the other one, the really big one, there's two of them that I would say that wordings that you need to know for the free response, and I'm gonna do that, and I'm gonna just because that question caught my eye, and that's a really good one. Okay. Now, the first one, and people that are in my class, you know what I'm about to say. It's find the particular solution. Okay. Sometimes it says find y equals g of x, the particular solution, but there's the words find and particular solution. Find the particular solution to the differential equation. That means we have to do separation of variables. That is the only technique for solving differential equations we have in AP Calculus. So that's like it's an if-then type thing, the type of thing y'all love, right? Every time they say find the particular solution, you're gonna do separation of variables unless like there's nothing really to separate and it's just dy dx is in terms of x, and you're just gonna take an antiderivative. But I think that would be too good to be true. So separation of variables. And then find the interval of convergence also for a Taylor series if you're taking the BC exam. That's where we're going to have to do the ratio test with the proper limit notation. People in my class are still resistant to the proper limit notation, just sacrificing credit. And then we have to also check endpoints. Okay, and those are two like major key things to look for. Because yes, good call. Thank you. Okay, yeah, I did not. I didn't get G. I got F. Or 1 minus x minus f. So let's get rid of this and go back in on that. Okay, Rohan, I hope you're still around. And so g, which equals 1 minus x minus f, all divided by x, is just going to be whatever I haven't read divided by x. So I'm just going to reduce the power by 1, and it shouldn't be too bad. Negative x over 2 factorial plus x to the 2 over 3 factorial minus x to the 3 over 4 factorial. Negative 1 to the n plus 1. I just lost a power from all my x's, so I'm going to call that x to the n minus 1 divided by n factorial. I'm going to make that look a little bit more exclamatory, but there we go. Big thank you. I have the test in 1 hour 20 minutes. Really? Are you taking it in in not the United States, I assume? Because that would be very early. I'm trying to think where you would be in the world if 1 hour and 20 minutes is 8 a.m. local time. Mo memory. Regardless of who you are, where you're from, like, best of luck to you. Okay, are the practice tests inside the Barron's book? Yes, honestly, and I haven't looked at your particular Barron's book, but my impression of the Barron's 5 Steps to a 5, Prentice Hall, or Princeton Review, any of those books, is that they generally are kind of a little off the mark in terms of Thailand. Nice. they're a little off in terms of the difficulty. Very frequently, they're a little more algebraic than the AP Calculus has been lately. The AP Calculus, not to get too much into like the theory of pedagogy here, but and as I'll go back to my things to watch for on the free response, I'm going to put on the screen. But with the Barron's book. The AP Calculus exam, we're really focused on graphical, numerical, algebraic, and verbal situations. And not, pretty equal weight to those. And so there's going to be more graph and table questions on the real AP exam than most of the practice books that I have seen. And that's why I so strongly recommend, it's not still on my clipboard, but I can just go grab this. And I got permission from the author of this book to share. There it is. Yeah, there we go. That's a review book that I really like. I can tell that the author of the book went and looked at actual AP exam questions that were either released or secure and like switched them around a little bit so they weren't exactly the same and made his own review book out of them. Okay, but even still, there's sometimes where that book's a little algebraic or a little bit too difficult. So to answer your question, yes, sometimes they are definitely too difficult. All right, so I'm going to scroll back and I'm a little behind. Number 18 on the 2016 practice exam. 424, that was you. So, on the 20. Oh, okay. This is a weird question. I used to use this one on my unit test for Taylor series, but I decided I didn't really like it, so I don't use this one anymore. That's where it came from. Okay, so here's a requested problem. Let P be the second degree Taylor polynomial for e to the negative 2x around x equals 3. What's the slope of the line tangent to the graph of P at x equals 3? Okay, here's the thing. I think that a lot of students like accidentally got this one right, but maybe they actually had kind of like a little bit of intuition about a Taylor polynomial. So you got e to the negative 2x, and that's not a polynomial, and it's hard to work with, but it would be way better if it was a polynomial. And the thing about it is, like e to the negative 2x, it's exponential decay. We do that in algebra too. And then, a second degree Taylor polynomial is going to be a parabola that fits it just right at, I don't know, this spot right here. And so, who knows? It might be something like that. The idea is it's got the same y-coordinate, the same slope, and the same concavity. So all we got to do for this one is we're just going to take the derivative with respect to x of e to the negative 2x, which is going to be negative 2 e to the negative 2x. And then we're going to plug in x equals 3, negative 2 e to the negative 6, and that's why it's a. Now you can go and you can write the second degree Taylor polynomial. That's what I used to do until somebody in my class was like, can't you just say that they have the same slope? And it's like, yeah, you actually can, because that's the idea of the Taylor polynomials. It fits just right. The same slope, same y-coordinate, same concavity, same derivatives all the way up to the, degree of the polynomial. Okay, now the next one I've got is number 86 on the 2012, and I'm going to have to go do a little bit of digging for that one, because my browser window's on the 2016, which is not a huge deal. I'm looking at 86. Okay, this one's gonna be really annoying to clip, but let's do it. I like these table problems. This is the exact type of problem that I feel like doesn't get enough play in the typical like Barron's or whatever, standard review book. The table and graph reasoning problem. So I have to snip this one in 2 goes. And a whole page to work on this problem. I don't think that's going to be necessary. I think probably most people are just looking at it and not writing anything down. Whoa, that was big. All right, yeah, this is going to be a little janky, but there we go. The arc sine of e to the negative x squared. That is, yeah, that looks exciting. So I'm just trying to see, Parsi on the 6 response is certainly, okay, 585, absolutely. So I'm going to be saying, all right, f prime is positive, and the integral from 4 to 7 is 0, which could be a table of values. This is the one I thought, somebody asked me one of these yesterday, I guess the day before, it's been frantic reviewing for the AP exam, and it was a different table problem. It was kind of the same idea. It was about exactly 2 critical points, something like that. Okay, so I'm just going to draw a picture. Okay, this is 4, that's 7. And the integral from 4 to 7 is 0. So it's kind of like, it's increasing the whole time because f prime of x is always positive. And so it's just like whatever this red area is has to be balanced out by the blue area. And we don't really know where the intercept is, but it has to be, that there's an intercept between 4 and 7 so that these areas are balanced. We know the function's continuous because we know f prime is positive, which means f prime is existing everywhere, and the function's always increasing and existing and being continuous because differentiable implies continuous. So I'm going to say I'm just looking for something that starts off negative and goes positive and has a 0 in the middle, I think. Okay, A is out, right? Because I know the 0 has to be between 4 and 7. Okay, B looks believable to me. C is out because F decreased from 5 to 7. Okay, that's good. D is not going to be viable because it's like a positive slope, so it's like actually what y'all would consider increasing at all times. And then 0, 4, 6, that's good from negative to positive. Okay, so I'm satisfied. It's going to be B. That's the deal with that one. And let's see, polar curves. I hope you're still here. I'm getting a little behind. The deal with the polar curves is like people mostly, okay, first things first, polar area. Area is 1/2 of the integral from theta 1 to theta 2 of r of theta squared d theta. That is a must-know formula. Okay. And we were so bad on that on the practice-free responses that I assigned a homework based on it, and if you did it, I think you're going to remember tomorrow. Area in polar world is 1/2 r squared d theta. I did not assign like a special homework before I gave you that problem, and in free response, if you don't know that formula, it can be, score can be low. So I'm saying, all right, area is 1/2 theta 1 to theta 2. Okay, so it's the area between the polar curves 5 sine 3 theta and 8 sine of 3 theta. And I'm going to say, okay, the mistake a lot of people made is they integrate from 0 to 2 pi on 1/2 of, and maybe we do 1/2 on the outside. So 8 sine 3 theta squared minus 5 sine 3 theta squared d theta. Okay, but this problem didn't come with a diagram. And it was just like a question that didn't have a graph or anything on it, but it was in the calculator section, so we needed to maybe do a little bit of analysis. And this is the only thing that I think that the polar mode is good for on the calculator, but I do have the calculator ready to go, and I've got it over here. I'm going to go in and turn the mode to polar. Where is that here? And then I'm going to go into R1 and I'm going to graph 8 sine of 3 theta. And notice it's going 0 to 2 pi right here. I'm going to maybe see if this will slow it down and maybe graph half as fast if I make it 0.5 instead of 0.1. But what I want you to look at is up here. There's this little yellow wheel that says hey, I'm graphing right now. I'm graphing your function for you. I'm working. And what you'll see is that it'll trace out the rose curve, and then the wheel will keep spinning. So that to me means it double traced, or at least traced more than it needed to. So we're going to graph, watch that. See, it's done on this one. For some, I think it might be because I have not seen this on a handheld calculator where you can actually see that it double traced. That would be nice. I'm seeing, I can tell it double traced there. So I'm going to go back in and just change it to 0 to 1 pi, and then graph again. And if you're really particularly concerned about this one. Maybe, I don't know, maybe it's pi over 2 or pi over 4 or pi over 3, who knows. You could keep cutting down the window if you wanted, but then if you cut it down any farther to, say, 3.14 pi over 3, well, that'd be about 1, right? And if you did that, you just get only not enough. And so now you know it's 0 to pi. Or you can, I mean, you can torture yourself with it, or you can just like, say, and what I really think used to in pre-calc class, I think even in the pre-calc class I took, I was supposed to know what the shape of these curves looked like. So people learned that if this right here was an odd number, it traced out on 0 to pi, and if it was even, it was 0 to 2 pi. But this is not that far back of an exam, so you had to go 0 to pi and use the right formula, and then you got the right answer for that particular multiple choice question. All right, the next one, number 22. I'm going to, Brennan, I would love to go over some Maclaurin series. I'm kind of just like going over, I'm kind of just taking the questions in the order I get them, and I'm trying to go as quickly as possible here. And so, but once I get to Maclaurin series, I'm gonna pull up, or maybe just write out the ones that we're supposed to know, and then because somebody, I mean, one of my students asked for a polar free response question, and I think I would probably just go back to the most recent one from 2 years ago. But number 20, I think the next one is going to be number 22 on page 373 of the book. And let's see, page 373. All right, so just scroll a while. All right, okay. Okay, so arcsine of e to the x divided by 2. Yeah, I have that wait, number 22. Yeah, I don't have x squared. I have e to the x divided by 2 on this, but I've just been working this problem. I'll scroll down to the bottom to make sure that questions over definite integrals stay along the same lines as number 30 on the all-topic multiple choice. I can answer that question while I'm setting up for the other one. All right, so distance and displacement. I know I have total distance on there. There was something I forgot to do on this. I thought it was distance and displacement. So I need to go back and look at the question. Number 30 on the all topics. And definition of the definite integral. Yeah, pretty much. I worked one earlier that was like a actual like looked like like a lot of things added together for this limit of the Riemann sum. But the most of them that I've seen, but also I forgot. I mean, I guess I'm gonna have to talk to somebody, before the exam tomorrow. But I've asked people afterwards, like, hey, did you see the limit of the Riemann sum on there? And nobody's ever reported they've seen it. But I'm sure that they're asking about it. People are just not even realizing, or whatever. Or just the versions that we've gotten at my school have not featured that line of questioning. Okay, so I'm going to go over here. I'm going to work the derivative question that was requested, and then let's keep moving along. So, so x divided by 2. So arcsine, I think I'm just going to, you know what, this is a perfect one for the O's and the I's. But this is a chain rule question, and I'm going to write down just the derivative rules that we need to know. So the derivative of arcsine x is 1 over the square root of 1 minus x squared. Okay, and remember, like, arcsine doesn't exist when x is bigger than 1 because, sine can't be bigger than 1. So, if I put something bigger than 1 in here, I'm taking the square root of a negative number, and that's not good news. Okay, that's the derivative of arcsine. And then the derivative of e to the x over 2, I think we'll just do that on its own. So on the outside, I've got arcsine of a thing. And on the inside, I've got e to the x over 2. And, when we were first starting out taking derivatives, I might have called this an outside middle and inside, with the middle being the exponential and the inside being the x divided by 2. But I think y'all are to the point now where you can take the derivative of e to the x divided by 2. It's going to be e to the x divided by 2 times a half for the chain rule. But we know that the chain rules is we multiply the derivatives of the outside and the inside. So outside prime is 1 over the square root of 1 minus whatever squared. And then inside prime is going to be 1/2 e to the x over 2. Okay, and oftentimes we can, kind of eliminate down based on this. So yeah, I think this is going to be enough. We need to have these two things multiplied together. And I think this was a little bit strange, but I'm going to have 1/2 e to the x divided by 2, and then I'm multiplying by that fraction, so I'm like having square root of 1 minus that thing squared. And I mean, it's just going to be c. Okay, we're not going to have a negativity out there. That's if you mistook the derivative of arcsine for the derivative of arc cosine. And so I can tell it's going to be this one. It's e to the negative x because what goes on the inside here is what went on the inside originally, right? And this always stays the same. And so we're going to square that inside. And if we square e to the x divided by 2, we just get e to the x. And so I have 1 minus e to the x on the inside, and I'm choosing c. And that was a good question. I liked that one. That one was a little challenging, but, good chain rule. So I just hit that one. A polar free response. Thailand person, your clock is ticking on you, but you've still got an hour. International free response problems are going to be. I grade the free response problems in the summer, but I haven't graded international in a couple of years. It's always nice to see the different ones. Then I'm thinking for polar free response, let me look at the 2016. I might do the 2016 because the Maclaurin series, is going to hit Brandon and Brendan's questions both. And, I'd like to do that. Where do I find, what? Get that from your side. I'll try to dig up number 6 from the 2016. Part C on the 6th free response question. Oh. 4, 5, 6. Whoa, wait, this is on the released one? Huh. I put this on one of the practice exams in class. Just partial wow, partial fractions integration guy. How's it going? I hope you had a good year. I heard you might have based on one of your friends' parents who I might work with. Really enjoyed having you in my class, man. So let's see. I'm gonna do and then I'll grab number 90 from this exam as well. Okay, so this is a Taylor polynomial problem, but not really a Maclaurin series question like the person was asking for. But I'm just going to do this one real quick to verify that it doesn't have a point of inflection. And Brandon, I assume this is the question you're asking me about. If it's not, please let me know, and I will work. I don't feel like this is off, but let's see. I'm scrolling back to. Okay, I found where I am. Part C on the 6th. Oh, part C. This is part D. Okay. Let's see. Okay, this one I do. I like to see it a little bit more, for the benefit of everybody. It gave us the fourth degree polynomial for f around x equals 1, and part C is asking us to find the third degree Taylor polynomial for g, which is the integral from 1 to x of f of t dt. Okay, what we need to see here is that g is an antiderivative for f, and I'm not even going to write that in. I'm just going to say, okay, I'm going to take the antiderivative of f, and I'm going to take it term by term. It's definitely the way to go. Okay, you can extract all the derivatives of f from the polynomial and then put them into the recipe for the formula for g, you don't want to do that. Or take the derivatives of g, I guess, and plug them into the recipe. And a lot? No. Okay, I just wanted to, on the logistic differential equations, no, there will not be a lot of logistic differential equation. You can expect to see it once or twice. There's only four things we need to know about it. We need to know the shape of the graph, the form of the differential equation, the special trivia fact about the maximum growth rate happening at half the carrying capacity and the fact that there's a point of inflection there. And I thought there was a fourth fact. I could see them asking you, the thing about the half the carrying capacity or like the carrying capacity itself. The Yeah, I know what UDV matrix you're talking about, and we'll talk about plenty of the second one in the sixth row next semester. But for now, let's do some calculus. I'm going to find the third degree Taylor polynomial for g, and I'm going to do that just by anti-differentiating term by term. I'm only going to need to anti-differentiate those first two. Okay, when I anti-differentiate 3 in a Taylor series world centered at x equals 1, you can just do 3 times x minus 1. And minus 6 over 3, when I add 1 to the new power and divide by the new power to anti-differentiate, that's gonna be my third degree polynomial for g. And then g of 1.1, I'm going to say is approximately equal to 3 times 0.1 minus 2 times 0.1 cubed. And I'm not going to try to be a hero and do the arithmetic because you're just running the risk of being wrong. I graded one over the weekend, this exact problem on one of our practice tests, that tried to be a hero with the arithmetic, was wrong, lost the point. Okay, we don't want you to do that. Okay, that was there. I think, Brendan, I'm going to have to postpone, I am going to go over Maclaurin series. I'm just going to wait till it comes up more naturally. And what I want to do is work the most recent polar free response question, which I believe happened in 2021. Now, I do believe that this one had something a little weird or challenging about it, but, we need to be ready for that too. I'd say we need to most be ready for the easy and medium questions. Okay, no, 21 had a kind of polarish part, but I don't believe it had polar on it itself. So we can go to 2019. I know that one for sure had a weird situation. I don't think would even be reasonable for us to go through. Let's see. Not much like the 2019 polar question. Let me go back. I think 2018 had a polar as well. It's the plankton cells. Yes, I like this one much, much better. Yeah, I'm going to do 2018 BC number 5. And I'm going to go pretty quickly on this one, because we've been doing a lot of polar lately, but I know some people in my class, they kept getting parametric on the practice exams, and, that's just how the cookie crumbles sometimes. Can't control what problem types we can get. But we can control what we're practicing on right now, and so that's why we're here, right? And I really do appreciate everyone being here. I'm realizing I don't have any way, I have no idea how, Wait, hold on. Yeah, I'm gonna jump in on the justification thing first. Mr. Pound, great seeing you here. And also, there's curiosity. How many people are currently watching? Who knows? I have no way of seeing. All right, I'm sure I have some way. All right, I'm going to start off over here. And so for the justification for a point of inflection, you're wanting to cite the sign change in the second derivative. I've scored those before. You can also cite extrema in the first derivative. especially if you're looking at a graph of the first derivative. You could say like, there's a point if there was this was f prime, and this is x equals 1, and it's like that. You can say f has a point of inflection at x equals 1 because f prime has a relative maximum, and that's okay. Extrema and the first derivative do correspond to points of inflection in the original. You could also say because f prime went from increasing to decreasing. You can say because f prime's slope went from positive to negative, because f prime's slope, we read that as f double prime. It's all about the second derivatives changing signs, though, and so I think that's the best. Okay, 24, that's incredible. I couldn't get 24 in my class when we were remote, and they were supposed to do that every day. Okay, so let R be the shaded region it's just the shaded regions. It's the moon-looking thing. And we're going to write an expression involving an integral for the area of R. All right, so I'm going to be like thinking in a very polar mindset, right, where everything is just like, doing this. And so, not looking at those, if I go and I reach from the origin across the thing, I'm hitting twice. Hold on, I wanted to go like this. I'm hitting twice. On the outside, I'm hitting the circle, and on the inside, I'm hitting the dimpled limaçon, or to you, just maybe like the weird curve. And you're looking and you see two curves, right? You see r equals 4 and r equals 3 plus 2 cosine theta. The one with a little bit of irregularity is going to be one cosine in it, so that's going to be blue. And we're going to say red is 4. Okay? And the most wonderful thing, they gave us the intersections. Okay. Oh, President Harrison, good to see you. Do you have like some other AP exam to be studying for? Wait, no, you're not taking the CalPC exam. You took it last year. That's somebody else in my multivariable. A couple of people in my multivariable are taking. But I think they're going to be all right. Okay, I'm just kind of putting it off. For part A, it's 1/2. This is like an outside minus inside thing, right? I'm hitting two curves at each time. So really what I'm doing is I'm going to take the area of that circle and I'm subtracting away the area represented by the, bounded by the dimpled limaçon. So that's going to be half of the integral from pi over 3 to 5 pi over 3 of first r squared is outside r squared is 4 squared. And then I'm going to subtract inside squared is 3 plus 2 cosine theta. And we need to be judicious with our parentheses here, but that's also getting squared. And max, min, yes, Sam, to answer your question, like what you are describing is great, provided that that second derivative exists. I might go and dig one up here in a little bit. I need to start, I'm going to start making myself a list of things to hit. And, I said this was 6 to 8, but I mean, I kind of need to eat dinner at 8, but I could probably, if there's more questions, then I can, take a 20-minute break to eat and then come back and answer more questions. That was part A. I didn't put d theta. That would be good form. But there was one on the practice exam where there was a sharp corner right at the point where it was crossing the axis, say from positive to negative, the graph of the derivative. And it was still a maximum, but f double prime wasn't negative there, even though f prime was decreasing. F double prime didn't exist because of the sharp corner. Why is that 4 minus 3 plus 2? Okay, so because I feel like this is the most durable part of this problem. I'm going to go in and I just want to try to draw this moon thing again, but maybe in a more exaggerated way. Okay, sure, this is going to work. That's the origin. So if I go like this, if I just integrated red, I would get all of this. Pardon me, it's going to be a really bad drawing. But I'd get all of this area. And to be integrating this, that's where I'm doing 1/2 of 4 squared. And then I need to subtract it to get the shaded region. I need to be subtracting away this area. And it comes from pi over 3, and there's some I need to be subtracting to the left or to the right of the y-axis also, but I think you see my point here. I'm subtracting away this blue stuff. And so really, I think the best, especially for you, I mean, you can use multicolored pens, you just can't cite the fact that there's different colors for, if it helps you work better. I mean, red pen, I mean, it might be a little risky because it might scan a little light. But I'm telling you, as a person that grades the free responses, it's black and white. That's all I can see is black and white. And so I think as long as you are marking dark, you're good to go. And also, oh, there's one of my guys that I need to let know that you can request extra paper, and maybe if the wow, yeah, this is classic AP Calc. So glad to see you here, Dominic. I know you're just probably killing it in a variety of math and other technical classes up in Canada, and maybe stay warm. I bet it's still cold up there, but it's getting warm here. It's gonna be summer very soon. All right, and for me, summer gonna be like tomorrow afternoon, I think. So, all right, what's happening? Glad to see you got it on you. The for you and for anybody that's unsure about this, take the integrals separately, right? 1/2 of the integral from pi over 3 to 5 pi over 3 of 4 squared d theta minus 1/2 of the integral from pi over 3 to 5 pi over 3 of 3 plus 2 cosine theta squared d theta. Look at them separately, kind of like the washer problems. Just like look at it as two different volume problems. Okay, so I'd say I'm gonna come back to this maybe. I would like to do definitely. I don't want to do the slope of the line tangent. It just takes forever to do the product rule stuff. But I am going to do part C because we didn't do any of these in class, and this does happen from time to time where they have like I mean, I don't. It depends on how you're looking at it. Parametric equations inside of a polar curve or related rates, something like that. Particle moves along a portion of the curve r equal the blue curve between 0 and pi over 2. So it's like, it's doing this. Particle moves in such a way that the distance between the particle and the origin, that's r, increases at 3 per second. So dr dt is 3. Okay, find the rate at which the angle theta changes with respect to time at the instant when the position of the particle corresponds to theta equals pi over 3. So we want to know, like, what's d theta dt? And so we've got r of theta. R equals 3 plus 2 cosine theta. And if we want to take the derivative of r with respect to time, we have to do this implicitly, all right? So dr dt, and the derivative of 3 with respect to time is going to be 0. Derivative of 2 cosine of a thing is negative 2 times the sine of a thing, but maybe theta is changing with respect to time as well, so we have to multiply by d theta dt. And they said that dr dt is 3, so I'm going to make that substitution. And then I'm going to say, and if this was my free response, I might probably like leave more of that one and like erase my work. I'm just trying to do this a little quicker. Pi over 3, I need it. It's the second time we've had to do unit circle in this meeting right here. 1/2 root 3 over 2. Pi over 3 is pretty far up, pretty close to pi over 2. So sine is going to be root 3 over 2. So 3 equals negative 2 root 3 divided by 2 times d theta dt. And then I'm going to just say, okay, 3 over negative root 3 is d theta dt. And that was something a little different. With finding the slope of the tangent line, we have to do dy dx equals y prime of theta, or dy d theta divided by dx d theta. Y is r sine theta, so 3 sine theta plus 2 sine theta cosine theta, and then x is r cosine theta, which is 3 cosine theta plus 2 cosine squared theta, and then you take the derivatives of both of those, plug in pi over 2, divide them by each other. It's a real long and involved process, and unfortunately for y'all, I've done it quite a few times in the past few days, so I'm just like, my appetite for it is gone. So I'm still not, Brendan, I don't even know if you're still here, but I'm still gonna go over some Maclaurin series, just like kind of when it comes up. Okay, Evan, I'm going to do question 8 on the most recent separation of variables homework. Yes, 14.5. Let me just pull that one. And, all right, 14. 5. I don't have that one on there, but I know what it is. It's the same homework I did. 7, 8. Y cubed cosine x. Number 8 on the most recent separation of variables. Y cubed cosine x, pi, and negative 1/3. Pi and negative 1/3. Okay. So I'm going to be solving this differential equation, separation of variables. Very important that we know how to do that. So I'm going to divide both sides by y cubed and multiply both sides by dx, so cosine x dx. Okay, then I'm going to take the antiderivative of both sides. And the antiderivative of 1 over y cubed is not log of y cubed, right? Take the derivative of log of y cubed. Think about the chain rule. Let's see why that's not true. 1 over y cubed is y to the negative 3. And we're going to use the power rule on this thing. The antiderivative of y to the 3 would be y to the negative 2. And then I'm going to divide by negative 2. And the antiderivative of cosine x, that's sine x, maybe plus a constant. Okay, and then I'm going to solve for y first. I'm going to multiply both sides by negative 2, and I get y to the negative 2 equals negative 2 sine x plus c. And, negative 2c, that's just going to be some new constant, so I don't really need to write negative 2c. It's going to be some other constant. If you write negative 2c, don't worry, we'll get the same answer at the end, provided neither of us make any algebra mistakes. Okay, then to get rid of this negative 2 power, I'm going to take both sides to the negative 1/2 power, so I can get y to the first. So I'm going to take this whole thing to the negative 1/2. Okay, but it would not be okay to just only take the negative 2 sine x to the negative 1/2 because of kind of the similar logic with plus c. That would not work because a plus b to the negative 1/2 is not a to the negative 1/2 plus b to the negative 1/2. You are not going to be able to do that. That would be an algebra error, illegal algebra. Negative 1/3 equals. Oh yeah, this one is bizarre. I think. Okay. There's something off about it being negative 1/3. Wait, oh, I know what it is. I took the square root of both sides of an equation, and this is algebra that you don't typically see on the separation of variables problem. But right, if I take both sides of the negative 1/2 power, that's 1 over the square root. If I take the square root of both sides of an equation, that does incur a plus or minus. Okay, so negative 1/3 is negative something to the negative 1/2 power. So negative 2 sine of pi. Well, sine of pi is 0 plus c. Okay, so 1/3 equals c to the negative 1/2. Square root of c, that was a little weird, and that's telling me c is 9. Okay, so my particular solution y is negative 2 sine x plus 9 to the negative 1/2 power. If you wanted to call that negative 1 over the square root of 9 minus 2 sine x, you could, right? Same thing. No need to. Okay, then the Okay, partial fractions integration problem. I'm gonna stick to current students that haven't already gotten credit for Cal BC from the AP exam. Stick to their questions. But if anybody wants partial fraction integration, we can do that. But my people were pretty solid on that this year. Why the antiderivative is what it is? It's okay. It's because I hope you're still here, Brandon. Okay, when I took the antiderivative of this 3, it really is 3x, right? But then there's also a plus c. And then minus, a bunch of other stuff that's going to have x minus 1s in it. And I'm actually going to do 6 divided by 3 is 2 times x minus 1 cubed plus a bunch of other things that all have x minus 1s in them, right? And we also know that g of 1 equals 0. Right? Because the integral from 1 to 1 of f of t dt has to be 0. So if I plug in 1, that's going to go 0. All the rest of the terms are going to go 0 because they have x minus 1s in them. And then this is going to be 3x, and so c would need to be negative 3, and then that's 3 times x minus 1. And it always works like that because they only ever ask you about an antiderivative. This lower bound is the same as the centering point of which you could not see, but because of my face, it's the same x value, so you can just know that when I anti-differentiate this, it's going to become that. Just saw your question there, Brandon. So I think the next, particularly requested problem is number 17 on the UDU versus UDV, which never a bad time to do UDU and UDV. I just need to go look it up. And you said, would you describe that? Second one in the sixth row. One, two, three, four, five, six. Okay, this one. Integral from 0 to 1 of x plus 1 e to the x squared plus 2x. All right, so, let's see. Oh, there's a dx as well. All right, so I'm thinking, okay, there's no numbers. Oh, okay, yeah. I am assuming this is the requested problem here. Correct. On the games per week, yes. It's the units of the derivative is the units of output divided by units of input. Units of an integral is where we multiply the units of output times units of input. Yes, trapezoidal Riemann sum, totally as you described, and I'm gonna just do one for the sake of somebody. I think really just needing to be reminded, where do the numbers go? How do we find the, how do we reconcile our geometry knowledge with our calculus knowledge and make sure we're getting our credits? Okay, so we're over here. We're looking at this thing, and it's like, okay, it's a weird integral, and I don't know how to take the antiderivative of it. I'm seeing a composition of functions, so that means it's going to be u du. Okay, UDV is not going to be composition. It's just going to be like a flat product. It's like e to the x times f of x, or e to the x squared. Yeah, e to the x multiplied by x squared on the outside. E to the x squared times x. Okay, something's the derivative of something else. What I'm seeing also is that the derivative of x squared plus 2x is 2x plus 2, and that's proportional to x plus 1. So I'm going to be letting u equal x squared plus 2x. So that du... in fact, I'm going to just because I know there are people here that aren't in my class. I don't know exactly how you do u substitution, but we're going to take the derivative of both sides. Du dx is 2x plus 2. And then I'm going to multiply both sides to try to solve for du. Du is 2x plus 2 dx, but that's not what I have. I have an x plus 1 and a dx. It's like outside of my u structure. So I need to solve for x plus 1 dx. So I'm going to say, 2 times x plus 1 dx is equal to du. And this is what I'm going for. So I need to divide both sides by 2 and say 1/2 du is x plus 1 dx. And, I know a lot of my people are going to go through this a little bit faster, but I just want to show all the steps. Okay, I also want to convert my bounds. So when x is equal to 0, I'm going to need to convert that to u's to take my integral all the way to u, so I don't have to go back at the end. Okay, u equals x squared plus 2x. So u is x squared plus 2x. That's going to be 0. When x is 1, u is x squared plus 2x, which is going to be 3. So now my integral to convert it to u's is going to be the integral from u equals 0 up to u equals 3 of e to the u. And then the stuff in yellow highlighter has become half of du. So I'm going to put the 1/2 out there and the du over here. And then I'm going to kind of just go antiderivative, plug in top, bottom, and subtract. All right, so I'm going to say, okay, antiderivative for e to the u, This is great. All right, so I've got 1/2 of e to the 3 minus e to the 0. And, if this is free response, that's a safe place to stop. If it's multiple choice, we're going to need to probably call that e to the 3 minus 1, all divided by 2. Okay, that was a... Right, I've tagged a lot of these questions as they've come. A problem with a trapezoidal Riemann sum. That's great. Midpoint Riemann sum, yes. Where was that midpoint Riemann sum? It was on one of the released practice exams. So I'm going to go back to, I think I'm going to take the number 28 on the 2016, and then I'm going to look for a trapezoid and a midpoint on that one as well. So just give me a moment while I go fish up some questions. All right, I might need to also take a break in a second to grab some water because I've just been like talking to the air. And Carter White is in here? Oh, man. Fortunately, that has not changed with time, and the harmonic series is still diverging, and everyone still knows that in my class. I'm very confident that my people are going to be knowing that the harmonic series diverges. I did not do as good of a job with like hectoring people on it in the hallway when I saw them. If I'm being totally honest, I've spent a little less time in the hallway this year, and kind of keeping to myself a little more. And but mostly just because I've got so many people like beating down my door wanting to work on calculus and algebra. It's been like a really positive year with the students in my class and working really hard and stuff. So I'm trying to see. This is 2016. I'm just in the free response. Okay, so I'm looking at doing number 28 while also looking for a midpoint and a trapezoidal Riemann sum. That was kind of ambitious, but I'm gonna go back to the free response and see if there's any trapezoid in action. I know there's midpoint. 16. Right Riemann sum in the free response. They're not gonna ask for a trapezoid. As far as the trapezoid, I might ask for somebody to find me a specific trapezoid sum question so that I don't have to spend like a bunch of y'all's time like scrolling. I'm gonna go do number 28. Oh, goodness. Sam, 28 on the 2016 release practice exam, no calculator multiple choice. I did that one earlier, and whew, man, I'm gonna show you my work for it. And that's going to have to be enough because I don't have it in me to do it again. This is kind of a rarer thing now to see. No, it's... Okay, I need to scroll back. Here it is. All right, this is relatively rare now that they would have you like grind through this entire thing by hand. In fact, this is live for A, B, and BC both. I would happily take any AB questions. You know, naturally, in the course of taking BC questions, 60% of them are going to be AB questions anyway, because it's the only difference is just like there's a couple of extra units at the end. So this is what I'm about to do right here. This is calculus AB and like really very traditional calculus AB. So, okay, total distance traveled is the integral of absolute value of velocity. And I dropped my stylus. And so that means we have to do this. But unfortunately, this is no calculator. You know, if we have a calculator available to us, we use Math 9, we use the absolute value function, we're really happy. This is great. We really hope that we are tested on this. You know, in AB, they're going to ask you about total distance versus displacement every time. In BC, they can ask you about total distance for a parametric curve, and we're still integrating speed. It's just that speed is the square root of x prime squared plus y prime squared, where x and y are both functions of t. Okay, on this one, oh yeah, I guess you could go back also if needed. But what we had to do is we had to split it up into these two areas, right? Because we want the absolute value of v. And the green area down here, this is representing like negative velocities. And so what I did was I computed red and green separately, and I just made sure to subtract red minus green to get my answer. But yeah, to see the actual, you know, integration steps, you could scroll back, but I'm telling you, like, have faith in your integration steps. You know how to do that part. It's just like knowing that you actually occasionally have to split it up and grind all the way through by hand. That's up there with like slope of a polar curve with like most labor intensive processes that we have to go through here. The midpoint Riemann sum, I know where to look for that, so I'm going to be doing that. It's pretty early on in this multiple choice. There we go. And, you know, pardon me for anybody that's in my class. Like, I definitely did this with the class this week, and that's the only reason I know where to look for it, because I just did it so recently. But I think this one's pretty representative. Midpoint Riemann sum is never going to be like a It's not like a huge gotcha moment. They're not trying to like kill anybody on a mid sum. And the thing is that the table has to be set up just right for it. And there's another problem that I'm aware of that I might work right after this one that I can't imagine them reusing, but another way that a midpoint Riemann sum could look. Okay, so they're asking us to compute the integral from, or estimate the integral from 0 to 6. Right? 0 to 6 with 3 subintervals. 0 to 2, 2 to 4, and 2 to 6. I mean 4 to 6. So if we're going to go over here and like find midpoints, it's going to be here at 1, 3, and 5. But the idea here with the Riemann sum is still the same. It's width times height. Okay, so the width of the first interval is 0 to 2, which is a width of 2, and the height we just get from 1. Okay, so we just go down there and it's 5. Plus width from 2 to 4, also 2. And then the height we're getting from x equals 3, which is negative 1. And then with the third interval, 4 to 6, width of 2. Height we're getting from f of 5, that's going to be 0. And I get 10 minus 2 plus 0 is going to be 8. And that's a midpoint Riemann sum. And I like this one because it's like, pretty friendly. But all of the ones I've seen with a table have been friendly like that, or they've allowed to use a calculator, spend free response, something like that. One that I've seen that was a little less friendly was, let me make sure, I think this is, okay, so Mango, I teach CalBC. But I also did tell our AB teacher at the school I work at to tell his people that I was going to be live tonight. And right now I am in the midst of working very AB stuff. I am going to go through and I'm going to do some BC stuff. I'm going to talk about some Maclaurin series a little bit later. And so there will be BC discussion that if you're in AB, you might be like, oh, what's this talk about? But you can just tune me out or maybe there's somebody else out there doing the same thing. I hope. I'm kind of wondering, like, why was I not doing this last year or the year before? This was extremely easy to set up. Big thanks to Mr. Schuler for giving me the technology tutorial. But anyway, okay, so, oh yeah, the other one is estimate this. With a midpoint Riemann sum and 2 subintervals of equal length. I think. I know that it's something to this effect, and that's not how you spell length. I know you had to take like 9 to the half and 9 to the 1.5. I don't think they would have you take 9 to the 2.5 power because I was thinking about it. I was like, I don't really know what that is. Okay, so 9, the integral from 0 to 2 of 9 to the x dx. Okay, so if I have like 0 to 2, and I try to do a midpoint sum, okay, my midpoints are going to be 0.5 and 1.5. Okay. So the width of each interval would be 1, and the height would be 9 to the x, where, okay, 9 to the 0.5, whoops. Plus the second one would be 1 times 9 to the 1.5. And then we would need to know that 9 to the 1/2 is 3, and 9 to the 1.5 is 9 to the 3/2. And just a word of advice on dealing with fraction exponents, deal with the denominator first. It's going to make your life way easier than taking the square root of 9 to the 3rd, which is 729, maybe, whatever. Maybe not. Maybe it is. Who knows? But if I take the square root first, that's 3 to the 3rd. That's 27. I like that. Yeah, I think it was the square root. So 3 plus 27, that's going to be 30. That's a midpoint Riemann sum for that integral. And those are kind of the two that immediately come to mind when I think of AP Calculus midpoint Riemann sums. Okay. Also, I just want to just quickly plug Carter White. He's got like some really informative educational videos on finance, and it's good stuff. I actually, he and I have pretty similar opinions on finance and things, and I would definitely endorse his YouTube products as well. If I knew how to suggest your channel in my chat, I would do that. But say just scroll up, click on Carter White, check him out, because he's got some good stuff. Let's see. Number 90, that sounds difficult, right? Last multiple choice question of all. Let's see what we got. Oh no, this wasn't. This is an old one. I went to 92. Sure. Okay. This is a cone problem where we have to use the similarity relationship, which is different from the cone problem that was on free response last year, where it was like the cone itself, its shape was subject to change. And then evidently this is a distinction you need to be able to make in AP Calculus now. And I think for too long, at least me and the other calculus teacher at my school, we'd been really training people on this problem type and only this problem type, and not ever actually taking the derivative of this volume formula with the product rule, which we definitely should have been doing. I think that left us out to dry a little bit, but somehow our scores were still pretty good, like always, because one part of one free response question or one multiple choice question ain't gonna make or break anybody. I really don't think it's all the hard work that you've done, like from August up to now. Sadly, I don't think you can really do that much between now and then, besides just sharpen up the things that need to be sharpened, like these one weird tricks. Like here, I've got a cone that is filling up with water. Height of the cone is 12. Radius of the opening is 3. It's always 3 and 12, it seems like. Water is poured into the cup at a constant rate of 2 cubic meters per second. Okay, so that means that dV dt is equal to 2. And now we've got water going into the cup. Okay, as the water level rises, if you think about when it was down here, okay, this triangle, the cone of water, is going to be proportional. It's going to be similar. And whether it's at the lower height or the higher height or all the way full. Okay, so radius to height is always equal to 3 to 12. And they want to know what's the rate at which the water level is rising. Okay, that's like what's dH dt. So we would like to use this similarity relationship to get rid of r. So I'm going to say r is equal to 3/12 of h, 1/4 of h. I think this is actually the same problem I did, but for some reason when I use it on my test, the answer choices are decimals, so I don't really know what is up with that. But this is 90 though, so whatever. Not worried about it. The r is 1/4 of h, and I'm going to make that substitution in the volume formula. So volume equals 1/3 of pi, radius squared multiplied by height, and radius is 1/4 of h. No, I think in my test problem it's 1/3 of h. It's a very, very similar problem. And so when I square 1/4 of h, I'm going to get 1/16 h squared. So I'd have 1/3 in pi and a 16th, so it's going to be pi over 48. And then h squared times h is going to be h to the third. And this is the type of thing I like to take the derivative of. It looks way easier, right? So I'm going to say dv dt is going to be 3 pi h squared divided by 48 times dh dt for the chain rule. And then I'm going to give myself even more room to work and say that that's 3 pi over 48. And then dv dt is 2, right, because of that. And 2 is going to equal 3 pi over 48 times the height of the water is 5 centimeters, so times 25 times dh dt. Okay, and then I'm going to multiply both sides by, but 3 and 48 can be simplified, and because this is multiple choice, I should probably do that. That'll be pi over 16. So I multiply over there, and I get 2 times 16 is 32, and then I'm going to have to divide by pi and by 25 to get dh dt. Pardon my handwriting, is pretty poor there. 32 over 25 pi, that's answer choice A. That's what I've got there. And all right. This was 90 on the 2016. Yes. 15 and 87. Surprised nobody asked me about this one. I'm not that familiar with this 2016 practice exam I'm learning this year. I think I've been giving it out to people before the AP exam. Maybe I think last year I just gave those out like on the weekend before and didn't, may have done Saturday school. Essentially didn't do that much. Okay. Yeah, I've seen like there was somebody else requested part of number four on the 2016 test. So man, maybe I should just do the whole number four. Okay, so I've got number 87. I believe this was for you, Prakar, and this looks like a calculator question to me. Okay, I think the integral from 0 to b of cosine of e to the x. Okay, there's going to be a fast way and a slow way to do this one. The slow way is going to be going into y equals and typing in that integral. Don't want you to do that. That would not be the thing to do. So, like, basically this is a function of b, because it's asking what value of b makes this integral a minimum. So I'm just going to say this is f of b. Is the integral from 0 to b of cosine of e to the x dx. The best way to do this is going to be just graph the derivative of f. So we can take the derivative of f, okay, by taking the upper bound of integration and throwing it in wherever we see the dummy variable in the integrand. So I'm going to say f prime of b equals cosine of e to the b. And then I'm going to graph that derivative, and I've got a calculator ready here. I need to turn it on and bring it up. I'm going to go over to y equals. I'm going to get out of polar mode, because there's really no reason to be in polar mode besides that one particular Rose curve question where you had to figure out the balance. Okay, I'm going to make that a little more visible. Cosine of e to the b. Okay, we'll do cosine e to the x. So it actually graphs. Okay, and then I'm going to graph this thing. Actually, no, it said on the intervals b between 0 and 2, so I'm not going to be looking at places I don't want to be seeing, so I'm going to do that. Okay, that was going to be a maximum because the derivative went from positive to negative, and okay, I think that the minimum is going to be happening right here, okay, where the derivative went from negative to positive. Okay, now this is the graph of the derivative. So f, the integral, is increasing, right? Because we're, adding positive area, but not that much, right? You can see there's not that much area there. If you wanted to be like really certain, what we could do is we could go manipulate the window a little bit. I don't want to spend too much time on this one problem, but I could do like -4 to 4. And I think that would, make it look a little bit more dramatic. And we could see that there's clearly a lot more area in the negative part, in this region here than there was over here. So the integral is going to go and it's going to be positive for a while, and then it's going to be negative. It's going to subtract down. It's going to end up being negative because this area will outweigh that one. And so the absolute minimum is going to happen right there. I'm going to calculate the 0. Remember, calculates where all the good stuff is between there and 2. And that's 1.550, which is answer choice D. Okay, and that's how I would do that problem. I would also, let's see, I'm going to go look and find another one. Let's see, it was requested, let's see, 15. All right, go look real quick. Yeah, sure. Little series action. We can do a little bit of series here. This will only be relevant to Cal BC students. I don't know for a fact I've got any AB students in here. I'm seeing a lot of names of people I know. But, all are welcome. It's definitely one thing we believe about mathematics. Everyone should be able to freely access mathematics, and we were not going to need a calculator for this one. All right, so what are all values of p for which the series diverges? All right, let's say if p is 0, the series is going to diverge, right? Because it'd be 1 over n plus 1, and that's a harmonic series, which we know diverges. Okay, everyone in here knows that one diverges. And then, but what I'll say is that if 2p goes bigger than 1, then the series converges. Okay? So I guess if we said that if 2p was less than or equal to 1, the series would diverge. and then maybe I'll just kind of like check the values of p that I get and see how I feel about it. So that's p is less than or equal to 1/2. Okay, let's think about some numbers that are less than or equal to 1/2. Let's think about -1. N to the -2, 1 over n squared plus n. Okay, then if p is less than 1/2, then 2p is less than 1, and then this n takes charge. It's like the biggest thing. And then if, it's 1 over n, it's more or less harmonic, and that's going to diverge. Okay, so what about p equals 1/2? When p equals 1/2, I have the sum of 1 over n plus n is 2n. I can factor out that half and say that's half of the sum of 1 over n, which is the harmonic series, which diverges, and that's going to diverge. So I'm going to say anything less than or equal to 1/2 will cause that series to diverge. We're 91 on the 2016 exam. We're getting a lot of mileage out of that 2016 exam. I'm really glad I ordered those copies. God, print shop people probably were getting frustrated with me. I ordered that like 3 or 4 times. Ordered a bunch of stuff, but y'all kept asking for them. Here. I definitely like this. A little bit of logistic differential equation. So the number of students in a school who have heard a rumor at time t hours is modeled by the function p, the solution to a logistic differential equation. At noon, 50 of the school's 500 students, quaint small school, have heard the rumor. At noon, which it doesn't really matter what t value noon is, but p is increasing at 20 students per hour. Okay, so we know that for logistic, as soon as they tell us logistic, we know dp dt is k times p times L minus p. And L is like the limit, the carrying capacity. And how much out of 45 would have... But the free response is out of 54 because there's 6 problems. And each is worth 9. Where do I find the 2016 MCQ exam? Well, I would start by Googling 2016 released AP Calculus BC exam. I'm not sure if this is my Allen or just some unknown Allen. But you could start with Google. If you can't find it, I can drop in a link to it. But I'll work this problem and let me know if you can find it on Google. If you can't, you should be able to because it's released. If you can't, I'll drop it in the link or drop it in the chat. So, and for the 5 on the 5 proportion on the free response, 5 is like 2 out of 3 or so. 2/3, 70% or so. So 70%, 2/3 of 54 would be 36 out of 54. I always say like 40 out of 54 is like if you're getting consistently in the 40s out of 54, yeah. Then you're on track for a 5. But some people are stronger on free response than multiple choice. Some people are stronger on multiple choice than free response. It just depends on what you're good at, and we just need to be collecting as many points as possible on all the sections of the test. And part of that is going to start with bubbling every question. Do not leave any of those bubbles blank, and do not leave any of those free response questions blank either. I don't want any NRs bringing shame on our school. Okay, that's enough. The L is the limit. And that's like the carrying capacity, the maximum possible number of people that could have heard the rumor. That's going to be all 500 of the people. So I'm going to make that happen. 500 minus p. And then at noon, that's like the data point they're giving me. When p equals 50, they say the rate is equal to 20. So we'll use that to solve for k. So I've got 20 equals k times 50 times 450. But this is a calculator problem. So I'm definitely good to use the calculator for this. So I'm going to say, I'll set up for the calculator, so I have to use it once. 20 over 50 times 450. And, no sense in trying to simplify it and taking the risk of, doing it wrong by hand, or I'm just going to type it in just as I see it. So I'm going to be quitting out of that menu, grabbing a fraction bar, that's a stat plot. I'm going to get a fraction bar, and I'm going to do 20 divided by 50 times 450. Actually, clicking these in is infuriating. Okay, 1 over 1125. That's okay. That is one minus choice. That had me a little nervous. And so that's what I'm going to say. 1 over 1125p times 500 minus p. And there we go. That's how I did number, what was that, 91. Why is p equal to 50? Because at noon, so they like the data point they're giving us is about 12 p.m. 50 of the students have heard the rumor. And like p is the number of students who have heard the rumor. And p is increasing at a rate of 20. So that's where I'm getting this data from. And so that would be why p is equal to 50. And I'm gonna grab that. This is unexpected. Let's see. 16. Right. I guess I didn't have this in Google Drive, but that's kind of surprising. I'm sure it's in here somewhere. All right, it's called document 5 for now, but you know this link that I'm about to drop in is going to be the higher chance of. I would say that the message couldn't be sent. Why is that? It's my own chat. Okay, there we go. That okay, Alan. Not sure if you're my Alan, but you know, who's ever Alan. That's the link to the 2016 practice exam. I swore I can't say if it's higher one versus the other. If you go back, you know, it's just like trying to read tea leaves, right? If you look back, like you can see you're going to be facing parametric or polar. Right? It's like yes, there will be free response that's parametric or polar, and I can't say which one it's going to be. I don't. No, I mean, like, we don't know. Last year was parametric. The year before was parametric as well. In 2020, that exam was, you know, like not even gonna go there. It was a good exam. Surprisingly good. I was really interested by the problems. Really like enjoyed grading it. Thought it was a creative way to give people college credit. But if we look back, I think the last time we saw polar was 2019. So if I'm studying for the exam tomorrow, I'm strapping up for some polar. Is what I would say. But I'm also going to be ready for parametric as well, because if there's not parametric on number 2 in the free response with calculator, like it could still be in 3, 4, 5, or 6 without the calculator. And if it's not in free response, then you can guarantee yourself it's going to be in multiple choice. They're going to ask you about parametric equations. That's like part of it. It's one of the key things that makes BC BC. So like, you know, they're going to ask about it. We don't know if it's going to be in multiple choice or free response. And I can say that paint polar with the same brush, right? We don't know if it's going to be multiple choice free response, but we know it's going to be there. Okay, okay, so now I think I'm going to switch over to Pracool. I don't know if you're still here, but I'm going to do the 4th free response question on the 2016 practice exam. And because there was multiple parts of that were requested, and that one's not going to allow the use of a calculator because only the first 2 allow the use of a calculator. And I'm going to go over here. Oh yeah, that's the salesman in the games. All right. A, B, C. Oh, C. You got me with that. Okay, who was it that asked for 4C? What is that was? That's a little far back. Oh, Pracool. Okay, Pracool. I'm telling you, like, you will be able to understand what I'm doing because you're, you know, a high quality calculus student. But I do think that this is a little bit more than what you would be asked to do algebraically tomorrow. This very, very strange problem, and this was the international exam, I think. So. I'm just snipping all the free response parts. Quick. Graph analysis is definitely the main one to study for. Taylor, for sure. There's going to be a table. Oftentimes it has a situation attached to it. Sometimes it doesn't. Rate in, rate out is one I would add to that. Differential equation, for sure. Parametric and polar. These are the main BC free response types. For AB, I would throw in implicit differentiation, area volume, and probably like motion on a straight line instead of parametric. All right, so let's go in here and work this number 4. Part C. Oh man, this is completely separate from the rest of the problem. Don't need it. This somehow dragged that up there or something. All right, and maybe I will get rid of this as well for now. Just look at this. Find the area of R in terms of M. And this is all the problem came with. It did not come with a diagram. So you need to know what e to the negative x looks like. That's why I've been training my Algebra 2 students on what the graph of e to the negative x looks like. Problems like this. Okay. And below by the x-axis, on the left by the y-axis, on the right by the vertical line, x equals m. Where m is a constant. And m is strictly greater than 0. Okay, that is region R, and now I've got like a really good sketch of it. A polar free response or a series one, yes, totally. If you go back, I did some work on a polar free response, like I'd say maybe at 6:30 or so, maybe about half an hour to 45 minutes into this process. So if you scroll back, and if you go back, it looks like the moon. It's like a shaded area that looks like the moon, or like a crescent moon. So that's the best I can do for you. For now, on polar, I am going to do a series one. I think I would like to work 20, like the one from last year. Just like show you what your friends that you know that took this class last year, what they were up against. And it was a little challenging. And the series is always challenging, but that's good. That's why you signed up for the course, was for the challenge, right? And the opportunity to get 2 college credits. So we're going to find the area of R in terms of M. Okay, so we're going to integrate from 0 to M. Top minus bottom. Top is e to the negative x. Bottom is the x-axis, which is 0. So I'm just going to integrate e to the negative x dx. And then I'm going to anti-differentiate. Antiderivative of e to the negative x is e to the negative x divided by -1 to prepare for the chain rule, right? Because the derivative of e to the negative x is negative e to the negative x. So I have that. You gotta be ready for that ready to catch that negative to come out. And then I'm gonna say this is running from x equals 0 up to x equals m. And that's gonna be negative e to the negative m minus e to the 0. Wait, no, minus, oh, that was a close call, minus negative e to the negative 0. And, because this is free response, I'm just going to stop there, right? We don't have to simplify that. And if we need to use that on a different part of the problem, like, we can simplify it then. Okay, but that's going to be all for that. I'm going to, okay, maybe, what's part B? That was a huge mistake. Probably connected a mouse to this thing. All right. Region R is revolved around the horizontal line y equals -3 to form a solid. All right, so I'm going to just kind of replicate not M, R again. Coloring in here. And I'm going to sketch the axis of rotation. I'm going to say that's way down here, y equals -3. And so I can see that when I rotate this around, yes, totally on me. And I believe that 2022's free response series question had the alternating series error bound where we had to justify our answer. Because I remember talking to somebody that was sitting at the table that was grading that problem, and I asked about it, and they said yes, and I was like, oh man, I don't think my people are going to be getting the credit for that, but that was why I focused on it so extensively this year. I don't know if it was as extensive as I wanted to be, but here I've got a large radius. I'm going to call this radius A in red, and then I'm going to write in a small radius which is going to reach from the axis of rotation to the near edge of the region I'm rotating. Okay, and since these are both vertical,
bars that are going to be top minus bottoms. So radius A is going to be top minus bottom. Top is the curve, y equals e to the negative x, minus bottom is y equals negative 3. And B, top is y equals 0 minus y equals negative 3, and that's going to be 3. And then over here, A is equal to e to the negative x plus 3. And this is right, but do not evaluate. So I'm going to say volume is equal to pi times the integral of large radius squared minus small radius squared. Okay, dx, because I'm rotating around an axis that looks like the x-axis. And what was I thinking here? Oh, yeah, and the x values, okay, on the left I've got 0, and on the right I've got m. And they didn't give me a value of m, so I'm just going to call it m there. And, you know, I'm pretty sure, you know, if you find your variables like this is okay for free response. But if you want to be just, like, absolutely certain that you're going to get all the credit, pi times the integral from 0 to m, you know, a and b haven't been defined elsewhere in this problem, so you should be good there. But we can do a squared minus b squared dx, and we can actually plug in a and b, so e to the negative x plus 3, and b was 3. Okay, and that's going to be an integral that would represent the volume, that strange looking donut thing. Okay, I just earned a subscriber, glad to hear that. I appreciate that, but not why I'm doing it. Just doing it to mostly to help the students in my class try to, you know, like if they're borderline 2 to 3, just eke out that 3, or they're borderline 4 to 5 and they really want to get a 5. I'm just trying to help people get to that next one. Why is it not negative e to the negative x for a? Okay, yeah. Let's see. I feel like I skipped. Oh no, I haven't done C, which was definitely requested by Prakar. Or no, that was Prakul. Pardon me. 2C and 2D. Oh, on the 14-2C. Rohan, you slid that one in there. I didn't see it. All right, so I'm going to do part C, which is completely unrelated to the rest of the problem. And I'm just going to tell you, this one's tough. Okay? What we need to know is just this fact, that the antiderivative of a to the x dx, okay, where a is just some base, right, probably a positive number, is going to be a to the x divided by natural log of a. Basically to prepare for the chain rule. And I'm not going to be going into why that's true right now in this setting, because I think I'm about to be eating dinner. It sounds like I'm going to be eating dinner. I'm really hungry, so I'm going to have to take a short break here. But I am going to work this problem, and then I was going to work. There's one other thing that sounded like possibly. Can you donate? No, thank you, not Dash. I wish that I had like somewhere to point you towards. If you were, what year is this question? This is the released 2016 exam. I think. I hope I'm not working a secure exam question. But if I am, I will make sure to mark this one private after the fact. No, yeah, please don't donate to me. I am well compensated by my normal job. This is just a little bit of extra work I'm doing for my students, and just for students around the world, I guess. I had one from Thailand in here earlier, which is cool. But I am a big believer in the AP program and the helping students earn college credit before they get there, to not have to waste money on calculus textbooks or the class or whatever. And especially for people that don't have to take a lot of math in college. Like, if you can get out of the way right now, that's ideal. And I think the most successful students in my class have been the ones that were going to study something like nursing or business, or only need that one math credit, got it from me, and then were able to take classes they were truly interested in college. So that was, I believe this will be up as an archive unless I have accidentally worked, secure problems. I'm not the most YouTube savvy person ever. I learned how to press go on a stream just this week, so but I'm not gonna switch it to private, because I did a test run this morning, and I learned how to switch that to private. All right, this is the antiderivative for a to the x. This is the formula we should know for AP calculus. It's not the most important formula. It's not like not like the derivative of sine of x equals cosine x. That's essential. This one's kind of fluff, but we're gonna need it. So if we're taking the antiderivative of k to the negative x, That's going to be 1 over natural log k times k to the x, but then we're going to also have to divide by, k to the negative x. We're also going to have to multiply by -1 for the chain rule, okay, plus c. Okay, but what I'm going to do is I'm going to just be JB. I was thinking about you the other day. I think it's because I've got a new JB in my class this year, a guy with the same initials. I've been taken to calling him JB, but you're the original JB in my mind, man. How's it going up there in Massachusetts? 2 semesters of calculus in college, and who knows? That might have been you might have missed out though. Cal 1 and Cal 2 probably would have been like child's play for you, but who knows? Like sometimes at those small schools, like the one you're at, like calculus classes can be like really difficult. Okay, so that's going to be my antiderivative. So if I'm going to go in and just do this problem, this looked a little sloppy and a little vain about my handwriting. If I'm doing 0 to infinity of k to the negative x dx, I'm going to say that's -1 over natural log k times k to the negative x as x runs from 0 up to infinity. And I did grade an improper integral last summer, and like I've always really stressed to my students, you cannot be doing arithmetic with infinity. But putting infinity as the upper bound on this like little bar, that's not counting as arithmetic with infinity. Oh, and I don't know who you are, but I somehow suspect you're in my class. It's all right. I'll respect your privacy, and I will solve for the radius convergence of that one. I'm going to tell you it's 3 right now because the exponential part in the denominator is what determines the radius of convergence. But I'll show you how we would do that by hand a little bit later. It might have to be after I break for dinner though. So I'm going to do this, and now we can't just be plugging in infinity for x. Infinity is not a real number. It cannot be plugged in like a real number. Please don't be abusing infinity notation. Don't be embarrassing me. On the free response. The Stevens differential equations, electrical engineering minor, cool. Getting your computer science, that makes sense. Okay, that sounds good to me. Differential equations, what a good class that uses all those algebraic techniques. I'm doing some differential equations with my multivariable class right now, but you already know that because you went through our multivariable class. Okay, so I'm going to say -1 over natural log k. I think I'm going to factor that out. And then I'm going to say this is, when I plug in infinity, I can't plug in infinity. I'm going to say the limit as x approaches infinity of k to the negative x minus k to the negative 0. All right, and that is going to equal 2. And it's like, how are we going to make that? Yeah, I mean, and especially if you're an actual scientist, like just for anybody that's just watching me work this integral, if you're an actual scientist, differential equations is like, that's the law of the land. Like any science. From physics to like hard science, life sciences, from my understanding, even like economic sciences or like social sciences, it's differential equations really like rules that world. Okay, so the limit as x approaches infinity of this, that's going to be 0, and so I'm going to have minus. Okay, yeah. So I've got -1 over natural log k times 0 minus 1 equals 2. So like these negatives are going to cancel each other off, and I'm going to say 1 equals 2 natural log k, so that natural log k equals 1/2, and k, I'm going to take e to both sides power, k is e to the 1/2. That's the answer to that problem, but that's like much harder than anything I've seen go through on free response in any of the oh, pardon me. Yeah, I did not. Oh, and I did not look at that problem closely. It's because of the 2n. It's because like that's kind of squared, so we'd have to take the square root. Pardon me. That's the type of question that I would just like kind of bubble quickly and move on and get wrong. But that's why we definitely don't need to get every question right. Okay, I'm going back and looking at the requested problems. I feel like I'm missing one. Also do 21. Okay, I don't know what 21 you're talking about. I'm going to look at the multiple choice, see if I like it. If I like it, I'm going to do it real quick. If I don't, I'm going to skip it. Because I know you have faith. You trust me to know what you need to work on. Yeah, I like this one. This one's quick. All right. All right, so number 21, the power series here has radius convergence 2 because it's 2 to the n, and it's just one power of n in the numerator here. Which of the following values of x can the alternating series test be used? Okay, 6 is going to be out because I plug in x equals 6. It's not going to be alternating, right? 4 looks possibly good. Yeah, 4 minus 5 to the n is negative 1 to the n over 2 to the n to the 2. That's a convergent alternating... Whoops, messed that up bad. N equals 1 to infinity. That's an alternating series to the n into the 2. That's a alternating series that's bigger on bottom, so it's going to converge. Okay, so its terms are decreasing in magnitude with limit 0. And so I'm going to say it's 4. We couldn't say 2 because if we did 2 minus 5 to the n would be like negative 3 to the n, and it would actually be bigger on top because of the heavier exponential on top. And 0 and negative 1 kind of the same story because they wouldn't be converging by the alternating series test, so 4 is the only one that's converging alternating series. All right, then the... 2C and 2D on the 14 2C homework. Yes, Rohan, those are the two I'm going to do before breaking to eat dinner. 2C, homework 2C, number 2C. Okay, I imagine my confusion. Parametric equations. Solid idea. Okay. How am I going to find this? Alright, I'm going to need to copy the question. This is blurry. I'm just going to preemptively apologize for how poor the quality of this one's going to be. But we're going to be able to see what we need to see. And yeah, that's job done. Then C and D. Alright, I'm going to just remember the prompt for D, and it's just like describe the behavior of the path of the particle as t increases without bounds. So it's like basically what happens if t goes to infinity. Like, just tell me what happens. All right, so let's bring this back. And here's number 2. This is from a released AP Calculus exam. In fact, I can tell you which one it is because I've got a legend. It's 2 is the 2008 International Practice Exam is what I'm working. Free response from that. Okay, and because this is number 2, it allows the use of a calculator, and I'm thinking I'd probably want to, yes, hey, oh man, this is, yeah, don't worry about series. Yeah, do not be worrying yourself about series, and don't be worrying yourself about parametric equations either if you're taking AB. I've done a lot of AB discussion in here, since I've been going for 2 hours, 13 minutes now, and, I'm going to do more as long as the questions are there. I'm going to do more. Trenton, it is really good to see you. I just want to double down on what I said last year at the end of the year. I just really, really enjoyed working with you. You're one of my favorite people I've had the opportunity to work with. And I've had the opportunity to work with a lot of really cool people. And I have a feeling you had a highly successful year this year, and I would be interested to hear about it. But actually, I get little tidbits from your sister every once in a while, and I've really enjoyed working with her too. She has not disappointed me at all. She's been just as cool as you are. So all right, so part C: is there a time t where the particle is farthest to the right? So is there a time where x is going to be at a maximum, right? Because the particle is just going along and just doing its thing, and there is a time. And that would be a maximum of x of t, and that was pretty rough. So series appears as number 6 on the BC test. Series appears in the free response for sure. Historically, it has usually been number 6, but not always. And I know sometimes on the international exam it has moved elsewhere. And I worked a problem I think it was O2 form B or something where they asked about a Taylor polynomial in number 5 where you had a table or something. But I would say if I was going to be putting money down on it, I'd say I'd be betting on number 6, right? And just number 3 is probably going to be the graph of the derivative, and number 1 is probably going to be rate in, rate out.
We don't know these things. We're not certain about them. Okay, so a particle's moving along the curve. Is there a time when the particle's farthest to the right? We need to graph dx dt and see what's going on here. Okay, so I'm looking. I'm going to type in dx dt. And dx dt is, and you know, if you have one of these nice calculators you want to use the fraction bar, type it in just like you see it. I am a teacher at a high school in South Texas. And 6 divided by x minus 3 to the 1/3 power. And I'm on a bad window. This is not the window I want to be on, so I'm gonna quit. No, wait, no, you act like you're turning the calculator off, and then it stops graphing. And then we're gonna zoom to the standard window. I probably, you know what, I'm gonna do that again and stop because I'm not interested in when t is negative. 0 to maybe, I don't know, maybe 20, right? Just to be, I don't want to miss out on any of the action, right? But see what's happening here. Like you can see, all right, linear algebra and differential equations. That 2 classes or 1 class at the same time. Okay, you know, current calculus students are looking at this graph and seeing that the derivative dx dt is always positive until what looks like about 2, and then always negative after that. And so because of that, yeah, there's going to be a time because x prime is always positive, so the thing's always moving to the right, and then it begins to move to the left at that 0, and then it only moves to the left after that. So explain why. Yes, my explanation is dx dt is greater than 0 on the interval 0 to 2, and dx dt is greater than 0 on the interval 2 to infinity. No, I had that backwards. It was positive and then negative. Okay, so that's yes to specifically answer the question. If yes, explain why and give the value of t. Okay, yes, at t equals 2, x is going to be equal to, what did they give us? They gave us x of 3 plus the integral from 3 back to 2 of x prime of t dt, as that is somehow just fitting in there. I'm going to go over here and, okay, look, the x of 3 is equal to 5 up there. We see that. 5 plus the integral from 3 to 2 of, I'm just going to call it x prime of t. I don't need to actually copy it. I've already got it stored into y1, so I'm going to use that. And probably good that we have one of these on the calculator. 5 plus, let me call for math 9. We love math 9. 3 back to 2 of, well, x prime is stored in y1. I'm going to get that from f4 y1 dt. And it is important that I integrate from 3 back to 2 because I'm going backwards in time. I need to subtract all of that leftward motion. It's taken a long time to think about that, but I'm going to get 5.792. And that makes sense to me that it would be at a greater x position at t equals 2 than it was at t equals 3 because it had turned around and started going back to the left. Okay, so that was C. I'm going to do part D, and that is probably going to do it for me before I... Oh, yeah, and explain the behavior as t increases without bound. That's probably going to do it for me before, I'm going to go eat some dinner, but it shouldn't take me too long. And I'll just put up like an away message like the old days, and if y'all know anything about that. So, take away the calculator. We don't need it for this. Okay, if a limit is not in indeterminate form and you don't use L'Hopital, you just solve the limit. So, yeah, if a limit is not 0 over 0, we just plug in directly on it. It's like a function that we just plug on. That does happen occasionally. If we get non-zero divided by 0, that's D and E. But the vast majority of like algebraic limit questions in AP Calculus are going to be L'Hopital's rule. And maybe I'll talk about justifying our answers on that at a different time. So I'm going to take the limit of dx dt.
as t approaches infinity. Because part D is like describe the behavior of the object's path as t increases without bound. T increases without bound, that means t goes to infinity. So limit as t approaches infinity of dx dt. You know what, I might just copy it this time. 6 over t minus 3 to the 1/3. Okay, well, as t approaches infinity, this fraction that I'm highlighting, that's going to go to 0. Okay, so that's negative 3 to the 1/3 power. That's the cube root of negative 3, which is a less than 0 number. Okay. And then the limit as t approaches infinity of dy dt, so t e to the negative t, I think it might be easier for us to, decipher what's going to happen here. So if we write it like that, limit of this, that's going to go 0 because the denominator is growing faster than the numerator. E to the t is growing really fast, t is not growing at all. Actually, why don't we just say this is the type of one, and I'd expect that, I hope all 100% of my students just say this is 0, but we could take the derivative of the top and the derivative of the bottom, and because it went infinity over infinity, and we could say that that's equal to the limit as t approaches infinity of 1 over e to the t, which is going to be 0. Either way, we need to know that this one's 0. Okay? So as a result, dx dt is negative at all times, right? We could even see that on the graph. So the thing's going to keep going to the left, but dy dt goes towards 0. So since and I could also say dy dx is like the limit of dy dx is going to be the limit of dy dt over the limit of dx dt, provided that they both exist, and the limit of dx dt is non-zero. Since the limit of dy dx is 0, then it's going to approach a horizontal line. But I'm going to say since the derivative of x prime is 0, or the limit of x prime, and the limit of y prime is equal to 0, it's towards the left along a horizontal path. Or it's going to approach some sort of like limit in y. I don't know what they said. I'm not really all that interested. I think that's a decent answer. Thank you, Trenton. You were an overpowered student, if I'm being honest. And just like a joy to interact with on a daily basis, especially 2 years ago. I know I've said this to you before, but like especially 2 years ago, like you and the people you worked with like really helped keep me going when it was not going so well. Okay, so I think I'm gonna come back and talk a little bit more about Maclaurin series for Brendan, who is probably not long gone. Might do a polar free response. Might also, just confused with the language. Oh, I also know somebody was asking, O and I, you were asking about that radius of convergence problem. I would like to do that, but I am pretty starving, so I'm gonna set an away message. I'm gonna mute myself. Eat some food. It's 8:22. I'm gonna aim for being back at 8:45. And what I'm gonna say is, if you have any requests, put them in the chat, please. And I will just like go back, scroll through the chat, and see what requested problems I haven't done or requested questions. But I'm gonna just do that now. And thanks everyone for being here. If I don't see you again.
Pardon me. I forgot I was muted. I do mind not eating. Because if I collapse here, I can't help you obtain knowledge. So I'm just going to ask you to remain patient, or like go watch something actually entertaining on YouTube for the next 20 minutes or so, and let me refuel myself so I can continue like imbuing you with calculus knowledge like you need to prepare for that exam tomorrow. Yes, Rohan, I love the sound of that. That is my best advice for test taking is make sure you got a proper amount of sleep and ate something before the exam. Okay, but not too much, right? I don't want anybody throwing up on the floor of the annex cafeteria. Okay, hey, and Rohan, I'm just before you leave, like, hey, did you know that the exam itself is in the annex cafeteria, not the gym? Okay. It is in the annex cafeteria. I was lying to everyone the whole time. Okay, so goodbye. Be back soon. People don't see my rule lines. That's embarrassing. Oh, hello. All right, I'm back. Okay, so I'm looking and seeing. Let's see, what was the last thing I saw? Oh, yes, I put a message in to mark where I was. All right. I can't. I think the thing with the calculator history, it's going to depend on the place you're taking the exam. If I'm being honest, I don't think it's in the script though. I don't think they tell you to clear the RAM on your calculator. And I know that that's a more common discussion in AP statistics. Yes, Anya, I know which multiple choice questions you're talking about. If you could somehow describe one more specifically, that would be good. I have not. I mean, I've done some serious problems. If you scroll back, but I'm gonna do like maybe a rundown of some serious stuff here in a couple of minutes. Zaid, if you go back, you will find me working number four on the free response portion of the 2016 practice exam. It was kind of, I think it was one of the last things I did before I broke for dinner. So yeah, you could scroll back on that one. So I think I'm seeing this intermediate value, mean value theorem, extreme value theorem thing in series mentioned explicitly. I'm trying to remember if there was one in I don't think there were. I think there was one. Oh, and I. Who knows if you're still here? You were here at the very beginning. I somehow hope you're not. Um, the but Zayd, if you got any other ones, I'm willing to work them. Um, Take a bite of this piece of bread. Yeah, I think I'm gonna go for series next. If anybody knows of a particular like intermediate value, mean value theorem, extreme value theorem problem, multiple choice, I mean, like I know 'em. We can scroll through and look for one. I think no matter what, in the interest of y'all's overall test taking success, no matter what, I'm calling it a 10. Because, my two pieces of test taking advice are make sure you get a good night's sleep and eat something before. And, I don't want people staying up all night studying for AP calculus. Not worth it. It becomes counterproductive at a certain point. So that's kind of the two things I'm thinking. If more things appear in the chat, I will work them. Oh yeah, yeah, I know. I know. I will. Anya, I'm not sure. I feel like you might not be the Anya that's in my class. Is this my Anya, or is this an unknown Anya to me? How do I do related rate free response questions carefully? The just I think yeah, narrowing down the answer choices on those which of the following must be true, which of the following could be false, especially that can be tough. Unknown Anya. All right, well, welcome. I'm really glad to have you here. I'm happy to work with you as well as my usual Anya, who I work with very frequently. Um, yeah, that's my Anya. Okay, but if you're studying for AP Calculus and it came up on your feed, then that means YouTube's doing its job. It's kind of incredible, honestly. Um, Yeah, with Alan and New Anya, I'm thinking of a couple that are coming to mind, and I'm eating a piece of garlic bread. It was really good, and I went and got an extra piece for just to snack on. It is. I did not make it. Jose, that's an interesting question about instantaneous rate of change. In general, it's just gonna be the derivative, but I'm not sure. You know exactly what instantaneous rate of change of what. In general, it's just the derivative of you know whatever you find the instantaneous rate of change of. All right, I'm gonna put down a piece of garlic bread. Found myself wanting longer for a dinner break than I had budgeted myself for. All right, here we go. McLaurin series. Pardon me. I was not trying to just like crunch in everybody's ears, but at the same time, I got to stay fed so I can make it to 10 if we're making that far. Okay, so with McLaurin series, the most important thing for us is to know the series that we have to know the formulas, right? That we should have on our formula sheet. That I don't know that I got to any of. I don't think I got to the McLaurin series in any of my sections, but we're pretty good on those. We need to know e to the x. E to the x, my mnemonic, it's the easy one. It's x to the n over n factorial. So it starts with 1 plus x squared over 2 factorial plus x to the 3 over 3 factorial, and so on forever. Okay, so that's x to the general term is x to the n over n factorial. That is actually an equality. Okay, we need to know sine and cosine. Okay, sine x. Okay, there's two ways to remember it. Sine's an odd function, so its Maclaurin series has only odd terms. In the trig series, they alternate. Okay, but also, for me, I think the more enduring one has been like, okay, I know what the graph of sine of x looks like near the origin, and these Maclaurin series are really based on what the graph looks like right at the origin. It looks like the graph of y equals x. So sine of x starts off with x, and then it alternates and increases in sine by 2. How delicious is the food? It was 10. It was great. Like, it was home cooked dinner. It was everything I could have asked for and more. Way better than I could have made myself. So, x minus x to the 3 over 3 factorial plus x to the 5 over 5 factorial minus x, odd terms, odd exponents, odd factorials alternating. We say it's alternating -1 to the n, x to the 2n plus 1, because 2n plus 1 is always an odd number, divided by 2n plus 1 factorial. This right here is Cal BC, but like in general, the purpose of our being here is reviewing for AP Calculus AB and BC, but if you're taking Cal AB tomorrow, you do not need to know what I'm talking about right here. This is a must know for BC though. And ... Okay, but I promise I won't spend too much time on this, and I will come back to the intermediate value theorem, mean value theorem, extreme value theorem discussion. I had just been promising a series rundown since like maybe 20 minutes into this. We're now at 3 hours. So cosine of x is 1 minus x squared. It's all the even powers. So that's like x to the 0 over 0 factorial is 1. Plus x to the 2 over 2 factorial, minus x to the 2, plus x to the 4. Logistic functions free response question. Very rare that like the whole problem is part of or is like that a whole free response question is logistic. I've seen one, but that was on a secure exam that I just gave recently, so I'm not going to be doing that one. I'll think if I can find something that's got logistic in it for free response. Practice problem for Lagrange error bound, happily. Yeah. I'll probably just go back and dig up the extra practice for that as I'm filling out this table of series stuff. Yeah, we'll definitely look at some logistic differential equations, and I'll go. I just lost a bunch of my Maclaurin series. Okay, and then there's one more we need to know, and that's 1 over 1 minus x, which is just a geometric series, and that's 1 plus x squared plus x cubed, and so on, plus x to the n is the general term. And that's only valid when x is between -1 and 1, right? Because this is geometric, and it's first term times 1 over 1 minus r, which is, okay, first term 1, r equals x. And so we've got that for certain values of x. Okay, then, very frequently they will ask us to do like manipulations, like substitutions, like sine of 2x. And with that, you just got to do exactly what they say and be judicious with your parentheses and not be making algebra errors, right? So maybe I'll just do like a real quick one. Let's say, we'll multiply on the outside and substitute. So maybe I'll say like x sine of x squared. Yes, Rohan, I am going to be doing those. Probably gonna try to do one of the intermediate value theorem, think about all the possibilities in the world and decide what must be true, type questions, and then I'll hit those from the series test because they would go well with this discussion here. But I want to leave this new on you hanging for too long. Being a guest and everything. So, all right. So what I might do is just like start with sine of that thing is equal to that thing minus that thing cubed over 3 factorial plus that thing to the 5 over 5 factorial, and so on. Oh, you know what? I'm going to change this from x squared to 3x. For reasons you might see or not, doesn't matter. And then I'm going to write the general term as well. First 3 terms in the general term. Formula for a particle at rest. A particle at rest is going to be where its velocity is 0. Plus, okay, -1 to the n, whatever to the 2n plus 1 divided by 2n plus 1 factorial. Okay, so if we're taking the sine of 3x, we just plug in 3x. We just got to be judicious with those parentheses, right? It's not 3x cubed, it's really 27x cubed. And if we're going to simplify that, then it becomes 3 to the 2n plus 1, x to the 2n plus 1. But if we want x sine of 3x, I'd really be like distributing an x into all of this, right? And and you're in IB. Recently, my eyes were opened to the world of IB math over the winter break, and I saw where you're heading, and it's good stuff. I don't know that there's as much focus on series as there is in AP Cal BC, but IB math, second level analysis and approaches. I think I had one of basically the strongest IB math course. I looked through all that stuff and it was like really good stuff. And so like you are in a good math class. You're being well prepared in the worlds of mathematics. Okay, so we're distributing this and then ends up becoming 3x squared minus 27x to the 3 with an extra x multiplied in becomes 27x to the 4 over 3 factorial. If you were to simplify this, okay, I don't even know what 3 to the 5 is. I'm just going to call it 3 to the 5. X to the 5 times an additional x when I distribute it in becomes x to the 6 over 5 factorial. And then really what keeps happening is I increase the power by 1. So I'd say -1 to the n, 3x. You know what? Because this is AP Calculus, we don't really have to simplify, so we'll just throw in the x there and just call it 2n plus 1 factorial and just call it a day. Okay, so hello, Sophia. Yes, I can do that. I'm going to look at that one. That's a and the multiple. Okay, Rohan, when you say multiple choice practice, are you talking about like the Unit 11 multiple choice collection? I'm gonna start looking there. So I'm gonna go there. I'm still thinking about looking for that, and I'll also go looking for an intermediate value theorem, extreme value theorem, mean value theorem type question. It's not going to be the right folder. Hold on just a second. Oh, I bet you were talking about the multiple choice like last second. Yeah, it definitely, that would make way more sense considering what day it is today. Great. 1499. Here we go. Okay, so let's see. Yeah, I see that. Uh, Thank you, Josh. I didn't do anything I knew before today, but I'm glad to know you now. How often do problems show up? Area volume. Okay, Sky Chan. Let me just jump in on that. Like, sample questions AP from. Okay, my magical dragon almost called you Michael. It's getting late. If you can you provide me with a hyperlink to that those sample questions from College Board? There's a lot of sample questions from College Board. I'm not sure if you're talking about the course description or do you also do A-level math past papers? Mr. Quad, I would love to do A-level math past papers. I'm not sure about like the rules on how those are scored. That's UK, right? I'm always interested in challenging but not too challenging math problems, especially at the secondary level. Okay, let me see. Sam, the more technical question there, I do not believe that I have entered the 14 fives. But if you've done it, don't do it again, man. Like, you're set, man. I'm losing track of the actual questions. Okay. So I'm grabbing 49 and 50. These are okay, but I feel like there's better questions out there. So I'm gonna like make a little rundown of the series tests. And thanks to one of the students in my class, made a mnemonic to remember all of the series tests, which I don't actually think is all that useful for a student, but it's very useful for an AP Calculus teacher when they're trying to like run them all down at once. Okay, so we've got D, direct comparison. R is going to be ratio test. No, not presented in any sort of like order, just to make it a mnemonic. L, limit comparison. A would be alternating series test. Wait. P for P series test. N for nth term test for divergence. And G for geometric series test. Big thanks to $9.99 in my third period for Dr. Leping. And so, there you go. New to me this year. People always come up with something new. Okay, direct comparison is where, like, okay, if we know that series 1 over n squared is converging, which we do know by the p-series test. And we've got a series of terms that we know are definitely smaller than the terms of 1 over n squared. Like, I don't know, maybe 1 over n squared plus e to the n, right? There's a number of ways we could show that this series converges, okay? But direct comparison to 1 over n squared would be one of them. Okay, converges because these terms are less than or equal to 1 over n squared for all n greater than or equal to 1. And so, you know, that's direct comparison. Smaller than a convergent series means converges. If I went and had the opposite kind of thought and I had, you know, the harmonic series diverges, which we really need to know, and we had something that was like bigger than 1 over n, like say 2 over n, or be something that's bigger than 1 over n besides 2 over n. 1 over log n, I think, because yeah, log n will be less than n for any n where log n is defined, you know, yeah, so 1 over log n is greater than or equal to 1 over n for all n greater than or equal to 1, and so, you know, as a result, the sum from 1 to infinity of 1 over natural log of n would diverge as well. Okay, that's direct comparison ratio test. You know, I don't know that this is the best use of our time here, me running through this, because you can see me doing this on video, you know, like a bunch of other places. You can go to my channel and search like Unit 11 Recap, Calculus BC. It's like on the front page, unit recaps. And I go through all the tests. So I'm starting to think like maybe that me running through all of them right now might not be the most efficient thing to do. I think I'm going to do number 49 and 50 on the last minute multiple choice, like you suggested, and I'm also going to put that in the chat. So that's probably good. And this would also be, you know, good, especially if anybody's new and doesn't. It's not like actually my class. You might be interested in this. This is all multiple choices, like from Mr. Quad. Yes. I would say, yes, you send me a link to A-level past papers. Basically just comment on this video, I think, and then I will find a way to, you know, get you an email address for me. But yes, I would be happy to do 1 over n to the x. Would it be a harmonic series if x is less than or equal to 1? It's only 1 over n. It's got to be like 1 or like a half plus a third plus a fourth plus a fifth plus a sixth, where it's like just 1 over and the denominator's just bumping by 1 each time. That's a harmonic series. Pretty much anything else is not a harmonic series. So I'm bringing out last minute multiple choice limits to Lagrange error bound. I'm going to do 49 and 50. And the nice thing about this this all-topic multiple choice is if you don't know me or you're not in my class, I think there's some people in here. Oh, I did not see Magical Dragon. I don't see the link. I've given the link. It sends you the website. Page number 31. Yes. Magical Dragon, I just don't see the link. Is there an answer key for all of these multiple choice questions? The ones that I just put in the chat? Yes, it is. It's on my channel. I'll find it for you because I was going to put it in there. It's like AP Calculus all topic multiple choice. Yeah, I found the link. It's a shareable link here. All of these multiple choice questions, like the 1 through 60 all topics, that is it like maybe that I'm not allowing other people to post URLs in the chat. If that's the case, I would love to be able to, figure out how to get somebody but I'm not totally, the most YouTube savvy person, especially when it comes to live. This is the first time I've done live in like 4 years. Okay. How do I... Okay. I'm grabbing 49 and 50 and getting back to my usual business, which is working problems. Trying to simultaneously navigate a bunch of technology stuff. But the nice thing about this practice set is that it does have links. Like if you don't know how to do a problem, it takes you back to my kind of like master Google Doc of, problems, videos, examples, etc. Radius of convergence? No, I have not. And, there was that one problem that O and I asked very long time ago now. Okay. So, what are all values for which this series converges? This is n to the 1/2 on top. This is n to the p on bottom. Okay, one big thing. Okay, that's Magical Dragon Eye. That is something I can work with. Okay, that's instructions I can follow. N to the 1/2 and n to the p in bottom. We need to be bigger on bottom. By more than 1 power. Okay, so 1.5 on bottom would be net 1 bigger on bottom, and that would be essentially harmonic, is how this works, especially if you're trying to work these multiple choice questions fast. So we need to be bigger on bottom by more than 1, so P needs to be bigger than 1.5. And that's where I'm going to say answer choice D there. And then I'm going to go grab number 50 right here, and I might actually just kind of point on this thing. So the integral test is what this is getting at. If the integral converges, then the series also converges, and the series is bigger. That's a fact, and you can you search my channel for integral test proof to see why the series is bigger. But if they're telling me that this integral is pi over 4, then I know that the sum from 1 to infinity of 1 over n squared plus 1 has to converge. So it's got to be 2, not 1, and 3 has got to be false, okay? Because I know that the sum has got to be bigger than pi over 4. But in this class, we don't actually, like, we're only able to find the sum of known Maclaurin series and geometric series. Okay, which gym, okay, I am not going to be in the gym, Miss Stivers. Pardon me. That was, I didn't realize that, yeah, good luck to you, 2 bolts. I didn't realize that all the BC exams are going to be happening in the annex cafeteria, so I'm going to be in the annex cafeteria collecting homework. I mean, like, probably like 7:45, I'll be over in gym 3, apologizing to people and redirecting them to where they're supposed to be. Those were 2... Sophia, I don't know if you're still here, but I'm going to do number 85 from the 2012 exam, the released exam. So let me just see. Yeah, this one, I'm surprised not more people have brought me this one, because this one's kind of tricky. That's a good chain rule problem. That's a good A-B discussion to have. And the other Anya, I've not forgotten about you. I'm not sure if you're still here, but like, I will go back and I'll look after this one. Okay. So the fuel consumption of a car in miles per gallon is modeled by F of S, where S is the speed of the car in miles per hour. The car is traveling at 50 miles per hour, and speed is changing at 20 miles per hour. Okay, so that means that S equals 50, and dSdt is equal to 20. Okay, and F of S is, I guess, F of S of t. So it's like the fuel economy at a speed, but speed is changing with respect to time. So this is definitely a chain rule situation. So what I'm going to do is I'm going to take the derivative of F with respect to time, which will involve just taking the derivative of f normally and then multiplying by ds dt for the chain rule. Okay, so the derivative of 6e to a thing is 6e to that thing. So s over 20 minus s squared over 2400. But then we have to multiply by the derivative of that thing. And so the derivative of s over 20 would be, I don't know, times 1/20th of ds dt minus 2s over 2400 ds dt. And I know I'm going off my shot. But, what I'm going to do is I'm going to factor out the ds dt from the right side of that expression, and I'm going to rewrite it so it looks a little bit better. Times 1/20th minus 1s over 1200, and then times ds dt. And this allows the use of a calculator. So I'm realizing that this is not the way to go at all. Okay, pardon me, I was not thinking clearly. Okay, we're going to use our calculator for this. And I'm going to just, admit defeat and go back over here. Hold on, where's my calculator? So I'm going to go and I'm going to just take the derivative with respect to, s of 6e to the s over 20, and if you want to use the fraction bar there, that would probably be smart. X squared divided by 2400. I know that's going to work on a PEMDAS level. That's the function at t equals 50. Okay, and so that's going to give us f prime of s, but it's like df dt is going to equal df ds, which I just calculated using math 8, multiplied by ds dt, which is 20. So I'm going to multiply this guy by 20, and I'm going to get 4.299 or 298, and I've kind of lost yeah, and here it is, answer choice B. Hey, that was a really good problem, very tricky. People have historically had trouble with that one. Then I also like the look of this. Okay, search up AP Calculus AB and Calculus BC sample questions. I am copy pasting your text into a search. First link, the College Board. I like the look of this. Okay, and then you requested page 31. Okay. For nice and proper integral question, let me, I'm going to just work it, because I just pulled it up on my desktop, not on the thing I'm writing on. So it says, for what value of k, if any, is the integral from 0 to infinity of kx e to the negative 2x dx equal to 1? All right. I'm thinking, I'm going to factor out the k because it's a constant. I've never seen this problem before, but I do like the look of it. Okay, this is a pretty flat looking product here. It's not like the derivative of negative 2x is an x or anything. So I'm going to have to use integration by parts. So u and dv. Okay, most people use Lipet or some other kind of mnemonic to decide what's going to be u and what's going to be dv. In my class, we use ILATE. Okay, just because that's what I learned from my teacher, and that's what I've passed on to mine, is the world history of integration by parts. But I like ILATE, where we choose u based on that acronym, and I stands for inverse trig, log, algebra, trig, and then exponential. And so I'm seeing exponential and algebraic. The x is algebraic and the e is exponential. So ILATE algebra before exponential, u equals x, dv equals e to the negative 2x dx. And if you need more on this, you can search my channel for integration by parts, and there's a lot of examples there. Du equals dx, v equals
plus negative 1. So we're anti-differentiating to find v, negative 1/2 e to the negative 2x. And one of the formulas we need to know for Cal BC is that the integral of u dv equals u times v minus the integral of v du. And if we're integrating from 0 to infinity, it's going to be like this going from 0 to infinity and that going from 0 to infinity as well. And so this is going to equal uv. So negative 1/2 x e to the negative 2x, so I might call that negative x over e to the 2x, u times v right there, minus the antiderivative, or the integral from 0 to infinity of v, so negative 1/2, so I might call that plus 1/2 there, e to the negative 2x du is dx. Okay, and now this is going to, require us to kind of strap up for a little bit, but be all right. Okay, what we're going to have to do is take the limit, because we can't just like plug infinity in there. Okay, we don't even apply that with an arrow. We're going to take the limit as x approaches infinity of negative x over e to the 2x. And then I'm going to subtract that antiderivative with 0 plugged in. Okay, so minus 0. Okay, so that just gave me a whole lot of nothing, because that's going to be 0 as well. Okay, plus 1/2 of, now I'm going to, basically do this integral over here. And Zaid, I don't know that I did respond to your question, I'm being honest. Okay, I don't speak your language, the FCE. So 1/2 of the, let's see, e to the negative 2x is antiderivative. So that's going to be e to the negative 2x, and I'm going to divide by the negative 2 for the chain rule. And so I'm going to let that run 0 to infinity, and so that's going to be, I'm going to factor out the negative 1/2, so I've got negative 1/4 of the limit as x approaches infinity, 1 over e to the 2x minus, I plug in 0, I'd have e to the 0, and I'm thinking that this is going to be negative 1/4 times negative 1 equals positive 1/4. And I know that that's, okay, I just computed that, so it's like k times 1/4 equals, was it supposed to equal 1? So I've got k equaling 4 on this problem. That was a pretty tough, number 3 on the pre-response question of the 2016 exam. Yes, Grubby Grub, this is A, B, and B, C. Zaid, I definitely did not do that problem. Anya, yes. I would not say it specifically for a school. I do work at a school, and most of the people here are in my class, though. Is what I'll say. So, Magical Dragon, there you go. That was what I've got for you. That was kind of a grueling question. Yeah, Mr. Quad is coming up blocked. As far as I can tell, just like, I don't know. You'll find a way. Find me. You can do it. I think I'm gonna go to Zaid's, and this Anya, I can't see your link. That's the issue, and maybe it's just time for me to go in to look at the settings on this thing, and there's like the, who can send messages? Anyone. Live chat is allowed. It's just like maybe community settings. I'm gonna not spend too much time on this, but options. I can't figure it out, and you don't want to sit and watch me try to figure stuff out, settings on YouTube. So, yes, yes, you can send it to the account that's linked to this one. If you email it, I will.
That's the address you can send it to. 3C and 3D. And yeah, that left side was completely zero. That was a pretty rough improper integral, if I'm being honest, with U and dv on it. I thought it was nice, but I would definitely assign this one for homework. Definitely not on the exam. The antiderivative of x from 0 to amount of money, magical, right? The integral from x from 0 to 1 of money. I mean, if I found 50 cents on my doorstep, I'd probably keep it, if I'm being honest. Everything in the bracket is a 0. So it's... Okay, no, everything in here is a 0. Okay, over here, this thing is going to be a 0, but e to the 0 is going to be 1. So I've got negative 1/4 times 0 minus 1, because e to the 0 is 1. And, okay, so Zaid, you're talking about the number 3 of the 2016 exam. I just don't know how to freeze just the screen in my classroom. I can't just freeze it. So I'm going to take this away briefly, and then 3 parts C and D. Okay, I think I used this one on one of our actual in class for grade tests too. Alright, so you're saying 3C and D, and Zaid, please stop me. Yeah, we can't really plug in infinity for e to the x, but if you plug in infinity for e to the x, it gets really big. If you take the limit of e to the x as x goes to infinity, that's going to go to infinity, and if it's in the denominator of a... yeah, Christopher, I do want to do that one. 2022 number 6, that is something that's on my list to do before I sign off, and I'm trying to sign off at 10, but if I have to spill over a little bit, I suppose that's all right. But I don't want people staying up all night studying for APCAT, because that's not productive. All right, so this is number 3. I'm clipping part C. Oh goodness, pardon me, Zaid. I am grabbing from the wrong test. Mean value theorem, yeah, sure. I got that. But this little time should be all right. Okay, yeah, some of my toolbars are showing, but it's gonna be all right. Yeah, whatever. All right, so I'm gonna do number 3, parts C and D for you, Zaid. Let me get to you. 2, 3. Ooh, yeah. This one's kind of a little much, but basically it's got some weird stuff going on here with like C is unknown, and if C's different, then the integrals are going to come back different and all that stuff. So if I go over here, average value of f over the interval -5 to c is 1/2. So the average value of f on -5 to c is the integral from -5 to c, 1 over c minus -5 of f of x dx. And that's equal to 1/2. Okay, so we're going to have to do this integral that I'm going to highlight, or we're going to have to do this integral using geometry. So I'm going to go back, and I'm just going to say from -5 to c, but we can do this and we can find it in terms of c. So the integral is going to be, all right, this is a quarter circle, but it's below the x-axis, so it's going to count negatively. -1/4 of pi times the radius is 2 squared, so I've got that being -pi. Then there's a triangle, and it's got height 2 and width 1, so that would be area 1, and so that's going to be a -1. And then here we have a triangle with
height 2 and width 2, and that's going to have area positive 4. And then this is 1/2 base, which is c, and height, which is 2, so this is going to be c units of area. Okay, so in total, this integral is negative pi minus 1 plus 4 plus c. So, you know, if I've got a negative 1 plus 4, that's going to be 3. So, negative pi plus 3 plus c. Negative pi plus 3 plus c equals 1/2. And then I guess we just solve this equation for c. I feel like I've done this one before, but this doesn't seem exactly all that familiar. I'm going to multiply both sides by 2 and c plus 5. So I'm going to have negative 2 pi plus 6 plus 2c, and I multiply 2, and that's going to equal c plus 5. And now all of a sudden this seems more reasonable. I'm going to subtract 1c over here. I'm going to subtract the 6. And then I'm going to add the 2 pi, and I think that will be it. C is negative 1 plus 2 pi. And that was a little tricky, but, you know, kind of a weird one. Assume C is greater than 3. Okay, h of x is f of x divided by 2. Find this one in terms of C. All right, we can do this. So, you know, if you're having trouble looking at it, you know, it's like on the outside we've got f, and on the inside we've got x divided by 2, which is just 1/2 x. And so I would say h prime of x, you know, we take the derivative of the outside while leaving the inside the same, and then multiply by the derivative of the inside for the chain rule. And I'm going to say, all right, we'll leave the inside the same. So that's going to equal f prime of 1/2 of 6 is 3 multiplied by 1/2. And okay, if c is greater than 3, then we need to figure out what f prime of 3 is. Here I am. Alright, so I can get rid of these geometry computations, but I wouldn't recommend you erase that on your free response booklet because, you know, like your work, you know, sometimes that work you do up top ends up saving you and getting you a point. So I need the slope of this line where x equals 3. Okay, if c is bigger than 3. So it really is just going to be like, I just need to do rise over run. So rise, it went from y equals 0. It went to y equals 0 from y equals 2. 0 minus 2 divided by run is c minus 0. So I've got negative 2 over c. And so I'm going to go and report that down there. F prime of 3 is, what's it? Negative 2 over c. And that's, I guess, negative 1 over c. And that was an interesting couple of questions. But, you know, I really don't think you need to do that. Okay, now, Anya, because you have been so patient, I am going to try to find that problem, and then I will go find, you know, other things. Might be... Okay, yes, Mr. Quad, you've also reached my email. You're two of the first people to ever email this address. Oh, Nimsy Materials, good stuff. Love the Nimsy Materials. I used to have access to this, and then with one of my instructional coaches. I can do a Lagrange error bound, and I bet I'm, yeah, bound up on time. So number 11 from this one. All right, 7, 8, 9, 10, 11. Yeah, good call. Okay, I'm gonna do that. I'm realizing I pulled it up on the wrong computer. All right, just a second.
Yeah, my email. That's frustrating. Alright. I like how they mentioned this is calculator allowed, but it's like it's not going to help you at all. Okay, so Anya, your particular question here. The function f is continuous on -2 to 1 and differentiable on the open interval. If f of -2 is -5 and f of 1 is equal to 4, which of the following statements could be false? Could be false is always going to be the hardest. Must be true is also pretty hard, but could be false is a good one. So if we know it's continuous on the open interval and differentiable on the continuous on the closed interval and differentiable on the open interval, there's a few things we know, right? If it went from -5 to 4, so -2, -5, up to 1, 4, okay, we know that at some point the derivative, like the instantaneous rate of change, has to equal the average rate of change. That's the mean value theorem. So what I would say is that the mean value theorem, because of the differentiability on the open interval, gives us that f prime of c equals 4 minus -5 over 1 minus -2. So that's going to be -1/3, right? Yes. Okay, so that's what the mean value theorem gives us. The extreme value theorem gives us that f of x has a maximum because of the continuity on the closed interval, has a maximum on and a minimum on the closed interval -2 to 1, right? If we're willing to consider critical points and endpoints. It's what we really need here is the intermediate value theorem, is that f of x is equal to y for all y that is between -5 and 4 at some x in the open interval. So -2 to 1. Okay, so that's what we need, is that f of x is equal to some number between -5 and 4. And so that's going to be... oh, I thought this must be true, pardon me. Which of the statements could be false? There exists a c where f prime of c equals 0. That one could be false, because it could just be that. Yeah, this is saying that there is a maximum. This one must be true, based on red. Okay, so I would say must be true. This one must be true based on intermediate value theorem. And this one same. And this would be extreme value theorem. And that's what I've got there. Let's see. Lagrange error bound. I'm thinking that the 2022, and so that's mean value theorem. 4 minus -5 is equal to 9/3. Okay, yeah, but still all the same. Yeah, I guess I caught that eventually. No, 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 no. No, like this is 9/3, which is 3. So like this one must be true because of that. I just didn't even put it together that I'd written 1/3. Okay. Okay. I think what I'm gonna do is, and then, A-level maths person, I'm gonna work that problem a different day. Maybe tomorrow while my kids are taking the exam and I don't have anybody in my class. Hello, Mia and Savvy. That doesn't really say anything though, it just says a period. The other one I was gonna do is 2022 BC number 6, and I've already got that on this page, so I'm gonna just go right for it. All right, so f is defined by the power series right there. And for all real numbers x for which the series converges. Part A is find the interval of convergence of the power series for x. Justify your answer. All right, so we have to use the ratio test to do that. Okay, and it even said to use the ratio test. And the ratio test is the limit as n approaches infinity of the absolute value of the ratio of the next term to the previous term. And so to get a n plus 1, I'm going to plug in n plus 1 wherever I see n in the general term. So that's negative 1 to the n plus 1. X to the 2 times n plus 1 plus another 1. Divided by 2 times n plus 1 plus another 1. And then I'm going to divide by an, so I'm dividing by the terms of the original, so I'm multiplying by the reciprocal. Okay, and then what I like to do with this is... uh-oh, that's not good. Hold on. All right, we're good now. Okay, so I like to, put all the x's together and put all the n stuff together. And I also like to just immediately get rid of the negative ones because we're taking the absolute value of this, so who cares, right? So, and we need to really make sure that we're maintaining limit notation here because we're computing a limit. Okay, and then the notation does matter in AP Calculus. And so what we're going to do is we're going to collect all the x's over first. So when I actually distribute the 2 over the n plus 1, I'll have 2n plus 2 plus another one is 2n plus 3. And then I have x to the 2n plus 1 in the denominator. And then the n's, okay, I have that 2n plus 1 in the top right. In the bottom left, I'm going to have 2n plus 3. Okay, and now I'm going to simplify this and be just really clear about it for anybody that's not in my class and hasn't done a bunch of these recently. So I'm going to have x squared times 2n plus 1 over 2n plus 3. We're taking the limit as n goes to infinity, so this is the only thing that matters, the only thing that depends on n. And as n approaches infinity, I've got, the same degree on top and bottom, and 2n plus 1 and 2n plus 3, so they're going to be closer and closer the bigger n gets. So the limit of this fraction that's in highlighter is going to be 1. And so this limit is the absolute value of x squared. And for the ratio test, if that limit comes back less than 1, the series converges absolutely. So I'm going to say x squared is less than 1 for negative 1 to 1. And then, okay, I need to check the endpoints because I can have conditional convergence there. Or convergence that I can only see with a different test that's not the ratio test. So at x equals negative 1, I'm going to plug into the series. Okay, I'm going to look and see that, okay, this is the sum. It looks like n starts at 0 of negative 1 to the n. So x to the 2n plus 1 over 2n plus 1. Okay, and then I'm plugging in negative 1 here. Okay, and negative 1 to the 2n plus 1 is always odd. So it's just always negative 1. And so this is the negative of the alternating series. And so I'd say, okay, this is an alternating series that's bigger on bottom, so I know it's going to converge. I'm going to say this converges because it's alternating. Okay, the limit of the terms is 0. Or actually, I might say that the size of the terms is decreasing. So 1 over 2n plus 1, that's the size of the terms, the absolute value. You could also just slap absolute values around the sum and write it off to the side, and but I say is decreasing. The limit of those terms is 0. That means this thing converges. This is why they give you a whole page to work this problem, because they expect quite a bit on the justification. X equals 1, we're going to go do the same thing, except 1 to the 2n plus 1 is just always going to be 1. Negative 1 to the n over 2n plus 1. Definitely in the interest of time, I'm going to say converges for the same reasons, because it's the same series, basically. So I'm going to say less than or equal to 1. That's my interval of convergence. That's part A. Okay, I've got, this is BC right now. Why was the 2 distributed to the +1 in the ratio test? Okay, so it's because it goes back to like, the idea is it's an plus 1 over an. And an plus 1, we're replacing n with n plus 1 wherever we see it in the formula. So that's like specifically that n right there is getting replaced with an n plus 1, and that too. And first n is getting doubled, and then it's adding 1. So n plus 1 is going to get doubled and then add 1. And that's why the 2 is distributed to the +1 in the ratio test. Question 2C from 2018, free response. Possibly, Mia and Sevi, I don't, it might be a controversial opinion, especially for people that are like here with me right now, but I don't know that like the amount that you studied today is the most deciding factor, or the amount you studied in the past week even is the biggest deciding factor in how you do in AP Calculus. So I'm going to do parts B, C, and D right here. Show that f of 1/2 minus 1/2 is less than 1/10. Justify your answer. This one was very tricky for my students, and I think very few of them ended up getting it right, and I doubt any got the justification point because I wasn't emphasizing it as much. All right, so f of 1/2 minus 1/2. Well, f of 1/2 equals 1/2 minus 1/2 cubed over 3 plus 1/2 to the 5th over 5, and, so on. So 1/2 is the approximation that I would get if I, what am I saying? It's the approximation I would get if I just used one term, right? So it's like I stopped here. Okay, so 1/2 is the first degree Taylor polynomial approximation for f of 1/2, basically. And so I need to say that this is a converging alternating series. Now we did already show that 1/2 is inside the interval of convergence, so you could use that, but I'm just going to say this thing converges. And I'm going to write out the alternating series test because I just want to be certain I'm getting the justification point, because it alternates with terms that decrease in magnitude. So what's the magnitude of this? 1/2 to the 2n plus 1 over 2n plus 1 decreases. And the limit of the terms themselves, so the limit is n approaches infinity if -1 to the n, x to the 2n plus 1 over 2n plus 1, with x being plugged in on with 1/2, pardon me. That is definitely equal to 0. Good. So I know that thing converges, and as a result, I can use the alternating series error bound. We can't use the alternating series error bound if we haven't first verified that it converges with the alternating series test. Okay, so now, because of that, I know that the error is no more than the absolute value of the first neglected term. And that's how I did part B. It was really all in the justification and recognizing that they were talking about alternating series error bound, really. But the alternating series error bound is just the next term. It's just the first unused term. Then we're going to write the first 4 non-zero terms and the general term of an infinite series that represents f prime of x. Right, so we're just going to take it term by term. F prime of x is going to be the derivative of x minus the derivative of x cubed over 3. Plus the derivative of x to the 5 over 5, so it would be an x to the 4, minus x to the 6th, plus so on. And then I'm going to take the derivative of the general term. We're only taking with respect to x, so this is the only thing that actually happens, right? We bring down the power, we're doing the power rule, and we subtract 1 from the power. Okay, yes, I'm not sure I know which is the most recent trapezoid Riemann sum, or trapezoid sum on a free response. 2n, and then the denominator is unchanged by us taking the derivative, but then we noticed, like, you know how, like, the 3 over 3, they always canceled? It's kind of the same thing here, so you could do that if you wanted. But that's the general term, if that's part C. And then part D is we're going to find the value of f prime of 1/6. So f prime of 1/6 equals 1 minus 1/6 squared plus,
1/6 to the fourth minus, so on. Now, I think we also needed to justify why we were going to use the formula for this one, and that's also something I don't know that I've like really emphasized even this year. I'm going to say is converging because it's geometric with r equals 1/6 and the absolute value of r is less than 1. So f prime of 1/6, we've got a formula for this, right? For our geometric series. It's first term times 1 over 1 minus r. And we don't have to simplify this as AP Calculus, we're just going to stop there. And that's the 2022 Cal BC number 6. I'll do AB as well. I teach BC, so like probably most of the people in here are for BC, but I am willing to take AB questions. Okay, so Christopher, that was for you. I don't even know if you're still here. I thought there was one up here that was somebody that was in my class that I was kind of like pushing off. Lagrange error bound. I've got, like Lagrange error bound requester. Let me just, whoops, searching it wrong. Hey. Show you, this might be a good thing for you. If you're looking for Lagrange error bound examples, that's something I might suggest. That's a video of me doing some Lagrange error bound practice. And really, like, if there's any specific thing that you have but you don't have an actual question on it, that's what I would recommend doing, is going to my channel or like going to the playlist that I have that's like AP calculus examples, and there's like hours and hours and hours of practice problems, and I'm not really seeing 83 Anvi. I don't know if you're still here. I'm kind of hoping that you're gonna start considering resting, but all right, let's see. 83 on the 2012. I think that's this one. This is the 2016. Huh. Hey. All right, so continuous. Wow, this is all the way back to like first days of school. One of the first things I told you. And appropriate because it might be one of the last things I'm going to tell you. The function's continuous. That means like it goes through the point we expect it to go through, and also like the value of the function is equal to the limit, and so that's going to be answer choice C. That's the only thing that really must be true. Is that the value of the function equals the limit from the left is equal to the limit from the right equals the limit in general. So that's how we did number 83 on the 2012 exam. Okay. Trapezoidal sum free response. AB. I can answer AB questions. I just need like something specific to point me in the right direction, if you know what I'm saying. And I do think, you know what, I think what I'm going to say is that, like, man, if you're in my class, like, we've been going now for 4 hours and minus, yeah, exactly. We've been going for 4 hours now minus the time I spent eating dinner. And you have practiced really hard all year in my class because I have just worked y'all like to the bone. And yeah, we got to be satisfied with that. We got to rest up and we got to eat something before the exam tomorrow. And I'm going to go super early and gather up all the calculators I have in case people don't have theirs or theirs is dead or whatever. And E must be true. Continuity implies critical point. No, not necessarily. Because like, f of x equals x is continuous everywhere and it doesn't have a critical point. Oh, I didn't see who that was. This has really brought people out of the woodwork. The number of people from previous previous years that I have seen tonight has just been like really heartwarming. Mr. Love, like I've said this much times to other people, but I really, really enjoyed working with you that year. And without people like you,
oh man, I don't know if I'd still be in this line of work. That was a particularly brutal year. I know it was tough on you. It was tough on everybody. It was also really hard on me. And but we had some good times solving some hard math problems that year, and that was like what kept me going. Yes, C is the correct answer choice on this problem. No problem, Zaid. Like, thanks for being here, and thanks for working hard all year. You're from Texas, taking BC. Yeah, okay. Maybe this year we'll see the Texas average be above the national average. I would love to see that. Yeah, Christopher. Yeah, totally. Que te vaya bien. Thank you, Miss Divers. Yeah, I'm gonna take a short break, and I'm gonna give people a chance. These people that I don't know, I'm gonna give you a chance to ask them a particular AB questions, and the put your particular AB questions in the chat. I'm gonna take like a couple minutes to refresh my water, check in with my family, you know, finish my piece of bread. So yeah, thanks everybody. I'm gonna mute myself now. All right, I'm back. And I'm seeing a lot of kind messages. Thank you, everyone. How many people are still here? Is this even reliable? Let's see. It says on live. I've got 33 viewers, it says. 924 views. Goodness. Wow. Okay, if anybody's got any A/B questions, any questions at all, throw them in here. Else, I'm probably going to be calling it. Let me see. I'm gonna like view it on my phone and see if there's anybody in here. It says. Oops. Oh, it says 32 watching. You know, if you're here, let me see. What would I suggest? School in for the summer, JB? For me, tomorrow. I've got a couple of sections of Algebra 2 and a multivariable calculus class I still have to teach, but I mean, it's really pretty much done. Stuck on slope field? What do you mean? Like making a slope field or staying in the lines when you're coloring? I mean, because slope field is like, it's coloring and staying in the lines. Like, you've got this, man. You can do it. Maybe I'll pull up one from AB last year. Talking about stuck on a slope field. I don't want you to be stuck on a slope field, man. A portion of the slope field for this differential equation is shown below. Sketch the solution curve through there. DO. Okay, let's talk. Okay. I don't want you to be stuck on slope field. I don't want you to give something incoherent if you get something like this. Okay. I'm not sure if this is what you're looking for, but this is a somewhat frequent problem type. Okay, I'll do this one. This is separation of variables we're gonna have to do. So yeah, we're gonna have to do separation of variables on this one. Let's do this one. Okay, this one was last year. Okay, the thing about slope field that I learned when I graded one of these for the first time, we're thinking like, just like generally following the lay of the land, not trying to be too fancy, coloring pretty thick, right? And I learned the rules here. What we gotta do, we don't have to be perfect. It doesn't even matter like where the curve goes. We have to extend the curve to the edges of the slope field. That's important, and that arrow was not necessary, so I'm going to take it away. We need to extend to the edges of the slope field, and we need to not have any flagrant contradictions with the slope field lines. Parametric, certainly. I'll do the parametric problem for last year, and I'll make a couple of commentaries on that. Okay, I mess up all the time. Okay, DO. Don't try too hard. Okay, with this, the coloring and staying in the lines, okay, the harder you try, the worse it's going to look. Okay, don't do it in pen either. Do this in pencil. Okay, but like, just make sure that, because it's not like, I grade the AP exams, and I've graded one like this before, and I'm looking at a scan of your document, and it's like, it's 1 point generally. And the rule is extends to the edges of the field. So like you just can't stop short, right? Like I had to go all the way to here and there. And I couldn't be like, yes, definitely parametric for sure. I can't just be like flagrantly off. So the flagrantly off would be like increasing where it's clearly supposed to be flat, or increasing where it's supposed to be decreasing. That's a flagrant contradiction. And so as long as we're avoiding those, we're going to be all right. The ones where they just give you like a few points and they have you do the slopes, it's generally like, you got to get the zero slopes right. Make sure that you have the places where slope is zero and you're like clearly horizontal. And then the rest of them is generally like positive, negative. If they're all positive, it's like we want to see like the more steeper, or the greater values of dy dx being steeper than the less great values of dy dx. But it's not, you don't have to be an artist. Okay, so write an equation for the tangent line to the solution curve in part A. It's the point 1, 2. Use the equation to approximate f of 0.8. All right, so we can write a tangent line. So I'm going to just do part B right here. So the point is 1, 2. Okay, that's my cat. I tried to bring him in for a friendly visit, and then he attacked, right? So, and I think he's going to have to go do that.
0.12. Slope, we have to plug into dy dx. So sine of pi over 2 is 1. So it's 1/2 times the sine of pi over 2 times the square root of 9, which is going to be 3/2. So my equation is y minus 2 equals 3/2 of x minus 1, and the approximation that they asked for, which I think was 0.8, is going to be f of 0.8 is approximately equal to, I'll add the 2 over 2 plus 3/2 of 0.8 minus 1.
Okay, and that's all we're doing for there. Very typical calculus point slope equation, plug in on the equation for a tangent approximation. It's known that f double prime of x is positive from -1 to 1. Is the approximation found in part B an overestimate or an underestimate for f of 0.8? We found that, and this is not part of your justification, right? But it has a slope of 3/2, and we know it's concave up. So maybe the true curve is like that at the point of tangency. Okay, we can even see that. Okay, so we know that the tangent line sits below the curve, and I'm going to say this is an underestimate because f double prime of x is less than 0 for x between the centering point x equals 1, so x between 0.8 and 1. And, oh, whoops, it's going to be greater than 0, but it's still an underestimate, right? Because the tangent line approximation that we got here, it represents, nope, there. Even if it was, it's still the same thing, right? Because it's underneath. And the true value of f of 0.8 is up here on the curve, so that's why it's an underestimate. Okay, and then part D is use separation of variables to find the particular solution. And I really do like this AB problem, but I don't think there's going to be time for us to do that tonight. And I'm mainly focused on BC because although I do appreciate all the people, I think I used to be more demanding too in my class until I actually graded one of these, and that's why that's why I'm such a big proponent of teachers going and grading the exams, because actually is really beneficial to know what the rules are, because they publish the rules, but even still sometimes they're a little vague. All right, so we're going to use separation of variables, so we got to get the y over here. So 1 over the square root of y plus 7 dy equals 1/2 sine of pi over 2x dx. That's separation of variables. Now I'm going to anti-differentiate both sides. Okay, this is 1 over square root of y plus 7. We need to write that as y plus 7 to the negative 1/2 power. And so I'm going to add 1 to the power. So it'll be positive 1/2 divided by the new power. That'll be a 2. Okay, I'm going to anti-differentiate 1/2 sine of pi over 2x. Okay, so I would be thinking negative 1/2 cosine pi over 2x. But I got to think about the chain rule on this, right? So when I take the derivative of cosine of pi over 2x, I would get negative sine. But I'd have to multiply by pi over 2, so I probably need to divide by pi over 2 just to make sure I'm not getting it. So make sure I'm getting a good antiderivative, and I'm feeling good about this. You can check your antiderivatives. It's probably good to mentally check them here. And I say, all right, well, 2 times, maybe I'll call this the square root of y plus 7. Handwriting is getting worse and worse. That's also a sign it's about time for me. Okay, and then I'm going to divide by 2, and so I'm going to have the square root of y plus 7 equals negative 1 over 2 pi cosine of pi over 2x. C divided by 2 is just going to be some new constant. And then I'm going to square both sides. Okay, and I just have to be careful to square the whole thing. This is I don't know, I'm sure, I know I worked this one right after the problems came out last year. Okay, now I have to go back to the initial condition and plug in on that. F of 1 equals 2, so 2 equals negative 7 plus something squared. So that's really going to be 9, so the thing is equal to 3. I'm plugging in 1, cosine of pi over 2 is 0, or yeah, cosine of pi over 2 is 0, so 0 plus c. seeing that C needs to equal 3. I'm kind of going a little fast here, but my energy's flagging right now. Hello, Big Whooper. Glad to see you here. Not sure if you're reviewing for AP Calculus. I hope you are, because if you're not, you're like in the wrong place, and you're not going to be entertained by this. And then I'm going to have my particular solution as y is -7 plus -1 over 2 pi cosine of pi over 2x plus 3 squared, and that was a pretty tough separation of variables for AB. Not that AB and BC have different difficulty of separation of variables. That probably didn't come out right. It's the same difficulty, of course. Just BC has more topics. But this problem wasn't on the BC test. All right, so the last thing I'm going to do before I call it is going to be BC number 2 from 2022, last year's. And I mainly graded last summer, I mainly graded BC number 5, the area volume problem with the improper integral and the UDV. And I graded that one, a few thousand times. And then I graded this one very briefly. I graded it like 10 or 15 times, but I did like go through the training on it. And I remember that there was like something a little weird about the way it was scored. Like they were very picky about part A, finding dy dx, and that's what I wanted to share with you. If you're here still, I'm going to do the parametric equation, and I'm going to do it, but I'm also talking about where we're getting the points, because that's a big part of my class, at least. Find the slope of the line tangent to the path of the particle at time t equals 4. So slope of the tangent line, that's dy dx. So what we know is that dy dx equals dy dt over dx dt. Okay. But what we're really interested in is the value of dy dx at t equals 4. And so what we need is we just need dy dt at t equals 4 over dx dt at t equals 4. And so, like, the simplest explanation, or simplest response that got the credit and they didn't run afoul of function equals constant is this. At t equals 4 equals, okay, y prime of 4 is natural log of 2 plus 4 squared divided by dx dt is square root of 1 plus 4 squared. Hey, don't even need a calculator for that, right? Because we just have to write an expression for it. Okay, but if you said dy dx equals log of 2 plus 4 squared over square root of 1 plus 4 squared, that's not entirely true, right? Because dy dx is dy dt over dx dt, which is a function of t. Okay, we're talking about dy dx equals t at t equals 4. And so that was the thing you had to be very careful about. And I didn't even drive too hard of a line on this in my class this year. I figured, because it's not always scored exactly like that. It has to do with the question later on a particular question, which is going to vary from year to year. And I just figured it wasn't even worth it. That's a little picky, but I mean, I understand the point. Can't be saying things that are untrue. For part B, find the speed of the particle at time t equals 4. It's going to be equal to the square root of x prime of 4 squared plus y prime of 4 squared. And that's going to be the square root of, okay, well, x prime of 4 is like the denominator of the fraction, so the square root of 17 squared plus y prime of 4 was natural log of 18 squared. Maybe I'll put an extra set of parentheses to be totally sure that's the speed. The acceleration vector of the particle at t equals 4. Okay, so that's going to be x double prime of 4 and y double prime of 4. Okay, and we're going to find that using the calculator. And that's, probably, if you get parametric equations on calculator, you should just like start off by plugging, x prime in y1 and y prime into y2. I'm going to have to go back and actually remind myself what these are. Okay, x prime of t is square root of 1 plus t squared. And y prime of t is natural log of 2 plus t squared. Okay. And now what I need to do is I need to take the derivative of both of those things. That's in math 8. Derivative of and I'm just going to call for y1, no sense in typing it again, at x equals 4. Okay, so that's x double prime of 2, or x double prime of 4, and that's equal to 0.970. Y double prime of 4, I'm going to just call for the same entry that I just made, and then I'm going to, and yeah, I forgot, with these new ones you can just reach up and like go up and select and copy it. But I'm going to overwrite this with y2, and that's going to be 0.444. Always round to 3 decimals in AP Calculus, and when using Math 8, make sure you showed what derivative you took, okay? Because you weren't going to be getting the credit if you just gave the vector itself without showing that you were taking a derivative. All right, once part C, find the y-coordinate of the particle's position at time t equals 6. Okay, we should all be so lucky to get a problem like this on our free response. Yeah, maybe I'll just shrink that somehow. Yeah. It's still legible. Yeah, kind of. I mean, at least it's there. So I'm going to hide the calculator for a second and get this thing calculator ready, and then we can type it. Okay, so y of 6, what did we already get? We had to get some initial condition. We got the position at time 4. So y of 6 equals y of 4 plus the integral from 4 to 6 of y prime of t dt. Okay, so that's going to be 5 plus the integral from 4 to 6, and you can, actually copy the function if you want, or you can say y prime of t, because we know, like, we're generally cone related rates. Yeah, totally. Actually, Abigail, I did one already, and you can scroll back. I don't know how far it is, but I even drew the cone, and I drew like water in it. So like if you scroll back, you'll be able to find me doing one. That's the cone where we have the similarity relationship. If it's not, then it's like 2022 BC, or like AB and BC number 4, and you can find the explanation on that. I mean, I worked it on my channel, and 1,000 other people also worked it on theirs. So I might not be able to do a cone, but I'll tell you, if you scroll back in this here video, you'll be able to find one. Okay, and then we're going to have the calculator do this job for us. So we're going to bring that calculator back in and say, now I want 5 plus math 9 from 4 to 6. Okay, we're going to do y2, because that's dy dt. 11.571 or 11.570. 11.571. Okay. Then that was part C. And then part D is find the total distance traveled by the particle on 4 to 6. I really think the reason they were so strict on part A was because this problem didn't really have anything very tricky on it. And so otherwise, they were going to have like a lot of 9 out of 9s. Because it's very, very computation forward. So part D, the total distance, that's going to be the integral from 4 to 6 of speed. Just like the total distance in AB is the absolute value of velocity. Well, the absolute value of velocity is the absolute value of a vector, which is something we find with the Pythagorean theorem. X prime of t squared plus y prime of t squared. This is also the formula for arc length, but if you think about it, the arc length is the same as the distance traveled on a parametric curve. I'm going to let the calculator do this because, that's definitely not going to be integrable to that square root. Okay, don't try to be a hero on the calculator section. Use the calculator to do your integrals, because most of them can't be done by hand. So this is going to be the square root, and most of the time I'd suggest my people in my class, when they hit parametric equations, I didn't do it, but I suggest they make y1 x prime of t, y2 y prime of t, and then y3 be x1 or y1 squared plus y2 squared. So y2 squared. So we could have just found the speed by plugging in directly on y3. That would also have been an option, but this one, the way I did it was fine too. Okay, I let that happen. That's 12.136. And that was last year's parametric equations free response problem. But if I'm being honest, I would, like, there hasn't been polar for a while, and I would expect polar. But, There's going to be parametric and polar on your BC exam, no matter which form you're taking or what the free response was last year or this year. That's a safe bet. And I think I'm going to call it here. This has been much better than I expected. So thanks for everyone being here, asking all the questions. Good luck on your exam tomorrow, or coming up here soon if you're in a different part of the world. There's a guy that was in here earlier that's definitely like in the throes of taking AP Calculus exam right now because he's in Thailand. Yes, I agree, Picard. It's time. Me too. I'll see you down there tomorrow. NX Cafeteria, 8 a.m. You've got this. We've all got this.